Next up, we're going to be creating a 2D side-scrolling platformer. We're going to have a character that runs around and jumps and avoids obstacles and needs to go from the start to the end of the level. We'll have a level loading system so that when you finish a particular level, it will load into the next level and so on. We're going to be using Unity's tile map system, which is a really powerful and flexible and really nice to use system to allow us to bring sprite sheets into the engine, slice them up, and then to place them down with some logic that says how those tiles should look. I'm really excited to make a fun platformer. Let's jump in and get started. Okay, let's talk about the game design for our project. I always like to start with some sort of diagram. I've got a 2D platformer, so I've got platforms that I need. And in here, okay, I need some ladders. You can see I've just scratched in here some notes with some arrows. I need some ladders. I need a start point and I need a finish point. And the finish point should trigger the next level. Need some enemies that I have to avoid. Enemies that preferably move around. That'd be great. Some hazards. So I've got these red things in here. Maybe it's lava. Maybe it's water. Maybe we have some spikes in there. Also, I've got in here orange to show the screen size, to show that I want a way for the camera to follow the player around, that we don't see the entire world at one point in time, because then everything's going to be too small on our screen. So we want this kind of moving television, if you will, that moves around and follows the player. So one of the cool things in this section of the course is we'll be using sprite sheets to make tile-based levels. What is a sprite sheet? Well, it's one image. You can see here, this is just one image that has a whole bunch of these little tiles that we can use kind of like Lego blocks to build out our levels. So this is a brick, these are different sort of bricks, this is an archway, and we combine those together to make something that looks like this. So this is TileVania, and this is the sprite sheet from TileVania. And back in ye olden days, when you were very limited by sizes of things, the amount of memory that you had, you needed to squash as much information as you could onto a sprite sheet, so then you could build all of this. So you can see we're repeating this kind of, what's this, green vegetation on the wall. That's that tile just there, I believe. And it's just, or maybe it's one of these here. And it's just been repeated and placed in a way that makes it look cool. So with a limited amount of information, you can make a whole ton of different levels. And other examples here, Mega Man you may have played back in the day, and Spelunky is a little bit of a more recent interpretation of using a tile-based system. So what I mean by tiles is each of these little squares in here is a tile, and then you go and place them. You build that and build that and build this. And in here you could have a base tile. It's a little bit hard to see, but you've got this base tile, and then you could have another layer that sits over the top where you have this little bit of flavor. So this green gem thing here and these little rocks. So you can have layers upon layers to give variation, but really you're just pulling from one or two sprite sheets. I mentioned before, back in the day, we needed to have sprite sheets to save on space. Nowadays, we've got a lot more room. We don't really need to be as careful with how much information we put on our sprite sheet, but it's still a great way to have one library of things that we then build a whole bunch of levels from. What's the player experience? We're going to be under pressure, so I want the player to feel I've got to rush to get through the level. The core mechanic is just running and jumping like most platformers and avoiding hazards, and the core game loop, get from A to B by navigating platforms and avoiding traps and enemies. And if we're talking about the theme, you might want to get a little bit of storytelling in here. What's the theme? For me, it's going to be you're trying to escape. You're a prisoner, the clock is ticking. Where are you? I don't know, it doesn't matter, but what we're saying to the player is get out of here. You've got to get all the way up to the top of the surface of the world. That's the theme that we're going for. And why do we come up with a theme? Well, it helps us pick our art assets. It helps us do our coloration if we're going to do some tinting or whatever to our world. And it helps us if we want to do some dialogue in there, and also helps us say to the player, what are you trying to achieve? And let's look at what are the core features we need to implement. MVP stands for minimum viable product. And basically that's a way of saying if we want our game to be playable, we need these minimum features in here, and anything else we put on top of that is gravy. It's bonus, it's awesomeness. But we need to have character movement. We need to be able to run and jump. We need to have traps or obstacles like this water in here that if you touch it, it instantly kills the player. Level loading, so a way to finish the level and restart the next level, or start into the next level to chain them together. And we need to have some sort of timer or some sort of urgency. This is probably not in the minimum viable product. We could get away without this, but I'm saying let's get it in there so that the player's got some sort of reason to push themselves and to jump quickly and maybe to make some mistakes because they're under a little bit of time pressure. And I might do this by having the water rising up to meet the player. We might think of another way to do it when we're actually in there executing. So I've got a challenge for you at the start here. I want you to find your art assets. Now, I will be providing you the basic sprite sheet assets for the world and for the character. That's the stuff that you see in here. I'll be giving you that kind of thing. But I encourage you, if you're ready to be a little bit more advanced in what you're doing, is to either flex your artistic muscles or to go find an asset pack from the asset store, and there's tons of free stuff out there and tons of paid stuff, so find something that you do like. It just needs to have sprite sheets for the world tiles, for the character, and for an enemy or for some enemies. So there's your challenge. Like I said, if you just want to use what I'm going to provide, then I'll be giving that to you in the next lecture. If you'd like to come up with your own artistic style or find your own assets, so now's the time to do that. And once you are ready, jump into the next lecture and we will start the process of slicing up our assets. Okay, see you in the next lecture. In this lecture, we're bringing our sprite sheets into our project and we're slicing them up so we have individual assets that we can be using as tiles, and we're going to be slicing them up using the sprite editor. Let's start by creating a new project. So from within Unity Hub, click on New, and then make sure you're selected on 2D. Name your project whatever you want. I'll be naming mine TileVania. I've already created mine, ready to go for this lecture, so that's why it's saying path already exists. Save it where you want to save it, and then click the Create button. As I said, I've already created mine, so go ahead and create yours. That will bring you to this screen. While yours is creating and getting started, what you might want to do against this lecture is to grab the assets that I've provided for you that you can download. If you've already got your own assets, you don't need to do this, but I've given this to you as a zip file. Unzip the zip file and have all these assets ready if you're going to use these assets. When you are ready to go, I'm going to, in my new project that should have opened up by now for you, hopefully it has, I'm going to highlight all of these assets and then drag them into my project, into Unity. That should bring them all in. Yep, nice and neatly. Let's do a little bit of structuring here. So I'll right click anywhere in here, create a folder, and we'll name this Sprites. And then let's grab all these things we just brought in, and then throw them in there. Now the assets that I'm using come from the Super Platformer Assets asset pack on the Unity Asset Store. Foxfin, the wonderful creators of this asset pack, have said that yes, you and I can use a limited subset of these in our student project to play around with, but if you want to use these in a commercial project, in other words, if you want to publish your game or sell your game or get your game out there, then you need to come along and buy this asset pack. Great assets. I've gone and modified them a little bit, so I've gone and colorized them. I've changed the sprite sheets around a little bit, so if you do go and buy that asset pack, things will look a little bit different. Just bear that in mind. So we've got a couple of sprite sheets in here, and these are all these tiles presented on one sprite sheet. If I was to drag this into the game and go blunk, there it is. It's not very useful, is it? We need to cut this up so I can say, just take this one tile and put it there, and this one tile and put it there. So there's a bit of a process I'll teach you now for cutting up your sprite sheets, but first of all, I want to get the size of these things correct, and I know from playing around with it that I want to have, if I click on my asset down here, I want to have my pixels per unit at 32. So I'm going to go and grab all of these. So the background, the coins, the enemy, the ladder, the ginger, that's the name of our player because he's got red hair, the spikes, and this thingy down the end, the exit. I'm going to change all these to 32 pixels per unit and then click apply. We've talked about this in other parts of the course. That means that for our graphic, our PNG that we bring into our project, we're saying we want 32 of the pixels from this image we've brought in to correspond to one Unity unit. And the Unity units you can see along here, this is one Unity unit, two Unity units, where our grid lines are showing our Unity units. So 32 pixels per unit is the size. It's going to look pretty good. If I just drag my character sheet in there, if I drag the character sheet in there, you can see that's roughly the size I want my character running around on the screen. Obviously, there's not going to be 50 of him, which is going to take one of those as he runs around, but that's a good way of saying, yeah, that's around the right size that we want. If I was to click on that and say back to the 100, then you'll see that it's way too little on the screen. It doesn't make sense. So back to 32. Now, I want to get these things out of my scene because I just dragged them in there to show you what's going on. So I'm going to click on the hierarchy and delete. And now what we want to do is find one of our sprite sheets. I'm going to click on our SPA, Super Platformer Assets, Rock, Grass, Water. And now you'll see from within the inspector there is a sprite mode. We want to change that from single to multiple. That says this is not one single sprite, this is multiple sprites contained within this area, contained within our PNG. And then click on the sprite editor button. I get a little bit of a warning. I've messed around with some things here, the pixels per unit, and I forgot to click apply, but it gives you a little warning, say, did you forget to click apply, Rick? You can click apply now, so thank you for that, Unity. And you can see here's our sprite sheet with our platformery tile things. Very cool, a little bit of water down the bottom. As I said before, I've rearranged the assets that I got from the asset pack provider. I've brightened it, so it's a little bit easier for you to see as I'm recording my video here. Now, up in the top left, we've got an option which says slice, and when I click on that, you can see we've got a few options: automatic, grid by cell size, grid by cell count. If I click on automatic, then what that says is, hey Unity, just go ahead and figure out where you think you should chop this up. And then click on slice, boom. You can see we've got a little white outline there. If I click on any of these, you can see that it's sliced it up exactly around where I wanted my asset to be. And also, as I click through it, you can see that it changes the name of it, _7, _8, _9. So it's given each of these an individual name, and it's sliced them up. Now, the last step in this is up in the top right. If I click on apply, then that goes ahead and does it. It makes this into separate images. What does that mean? Well, let's X out of our sprite editor, find our sprite sheet we're working on, open that up by clicking the little arrow thingy, and you can see now it's got all these individual sprites. It's chopped it up. If I was to grab one of these and drag it into the scene and drag another one into the scene, then these are now individual assets that we can use within Unity, all being pulled from our one singular sprite sheet. So that stays as a single asset, as a single sprite sheet. We've just given some logic to say how it's chopped up and how it's presented. So once again, I'm going to delete all those because I was just mucking around and showing you how that works. Okay, so that's for our rock assets. We're going to do a similar process for our background, but I'll get to that in a moment, because what I want to show you is a slightly different way of doing things with our character. So click on the character, jump over to the inspector, change from sprite mode single to sprite mode multiple, click apply, don't forget that, then click on sprite editor. Now we can see with our sprite editor, if I was to go up to slice and click on automatic and then say slice, it will slice exactly around the pixels that it sees. It's like, okay, you've got pixels there, I'm going to hug the corner of these exactly, hug the corners. And that might seem like it makes sense, but if you see, we've got a little bit of a run and a little bit of a jump and a bit of a roll in here. And if you just look at this exactly, you can see that my character is at this level as I scroll along. You can see that it's gone up a little bit higher, up a little bit higher, whereas the slicing is still right around the character. So that means it's not going to translate the character up and down within this area. So if I want to retain this artist's good work of saying he's kind of jumping up in the air and then down, or when he does this roll that he's on a particular plane, then instead of doing this automatic technique, I'm going to jump up to slice and click on grid by cell size. And you can see we've got these red outlines that have been presented everywhere. Now, I've gone and played around with this before I started the lecture, so let me put it back to what the settings possibly were before we started off. It's probably like this, 64 by 64, 0 padding, and you can see that the big red lines which says this is where we're going to slice this up, it doesn't match up to our character at all. I'm going to make our pixel size 32 by 32, and then I also know, just because I know this and I've looked at it and I've measured it, I know that there's a padding between this. So the artist has created this saying, I'm going to make a block and then I'm going to give a little bit of space between it and block, a little bit of space, as we had for our other assets. You can see just a little down here, you can see there's a block and then a space and a block and a space on our rock assets we chopped up before. The same thing is taking place with our characters. So clicking on slice again, I'm going to add some padding of 6 and 6, and that means that we slice up our sprite and then a bit of a padding, slice it up, bit of padding, slice up, bit of a padding. Perfect. So that is now looking pretty good, except I keep clicking off it. When I click on slice now, it will slice things up and show our white outline. So you can see when he's doing his little rolly thing here, he's off the ground a little bit, which I think is what the artist wanted. And if he's doing this kind of jumping thing, he's off the ground. Once again, as he's doing his little run, there's a bit of a bobble up in the air. His legs go up in the air, so his head's staying at a similar height, up and down a little bit. So anyway, that's the better way to slice it up when you know that the artist is working within a block, but moving the character up and down within the block. Once again, we hit apply. Then X out of this, and you can see if I click on my character, open that up, you can see a whole bunch of, we've got our assets in here. Now, I've got another couple of things to do. We've got the enemy, got the coins, and got the background. I'm going to set this to you as a challenge. Slice up those sheets, slice them up so we have clean individual assets for background tiles, platforming tiles, the character animation, which I've done already, the enemy animation, which you've got access to, and anything else you might have cooked up when you went and grabbed assets or when you created your own assets. So there's your challenge. Pause the video, take that on, and I'll see you back here when you're done. Okay, I'm going to do this pretty quickly because we've already done it a couple of times. Click on the background and make sure it's at 32 pixels per unit. Yes, change it to multiple. Click on Sprite Editor, apply, because I forgot that again. Up to slice. I'm going to put this back to automatic and slice, and that's done it around perfectly. Excellent. Then click apply. That one should be all done, and looks like it's all done. Great. And then what we've got here, we've got the coins. Let's click on that, change it to multiple. Once again, click apply so I don't forget like I do every time. Click on Sprite Editor. Now, how are we going to do this? Well, let's see what happens if we do grid by cell size with the 32 and the 6. That looks perfect. Looks like these coins are right in the middle of it. You can see that it's rotating around. Great. So I'm going to click on slice. Then click on apply again. That looks good. And then what else have we got? We've got our enemy facing to the right. Once again, change to multiple. Click on apply, sprite editor. I think this is going to be, if we click on splice, grid by cell size. That doesn't look like it's worked at all, does it? Let's see what happens here. We've got this offset. I didn't tell you about this before. Apologies for that. But maybe if we do an offset, that will move all of the boxes along to the right, because it looks like this wasn't cropped all the way on the left. So if we put it to 6, how does that look? Not quite there yet. If we put it to 10, then on the lefty-righty, it looks like we're pretty good. That guy fits in, that fits in. But on the uppy-downy, not quite. So I'm going to put a little bit of padding as well. What happens if we make this fully 10? That's too far. And if we make it 6, you know what? We need a little bit less than that. I'll make it 4. Okay, so I hadn't mentioned that to you before. Apologies for that. But we do have a little bit of offset that we needed for this slicing up this character. If you figured it out yourself, well done, being a clever sausage. And if not, then we've done it now and we've sliced this up. Looks pretty good. I'm going to click on slice, click on apply, X out of that as well. And the ladder is sliced up already because it's one individual unit, and the spikes are sliced up already. So I believe we have done everything. Oh, and the exit is as it should be. So there we go. We've sliced up our sprite sheets. I will see you in the next lecture. Hello and welcome. In this lecture, we're talking about tile map. We're going to be setting up a palette and then creating just a really simple, basic platformer for our game. So let's get started. Let's start with a little bit of terminology about the tile map pipeline. We've already chopped up our sprite sheet to create individual sprites that we can use to turn into tile assets, which we'll be doing in a moment. Those tile assets we can add to a tile palette, which is kind of like an artist palette. You know, the blue that allows you to paint here and the red that allows you to paint there. This is our tile map palette. And then we're going to add those onto a tile map that will allow us to create our scene with platforms and background and all that good stuff. We'll be going through this flow, which is also our challenge for this lecture, creating a simple platform. First of all, we need to create a platforms tile map. What I mean by platforms is the things that the player runs around and jumps on, the actual platforms. And then we need to be creating a tile palette to paint onto the tile map. We need to format our tile palette, rearrange things a little bit if we need to, particularly to flip the things that we've only got, say, a left side of in our assets. We need a right side as well, and then we'll paint just a very simple platformer layout. So in Unity, let's right-click in our hierarchy and create ourselves a 2D object. This will be tile map and rectangular. Rectangular gives us all these lovely grids. This is our tile map. So basically it's saying in all these particular grids, you can put a thing in here. You can put a piece of information. And from tile map, I'm going to rename that to be, let's see, platforms tile map, just so we know it's for the platforms. Later on, we're doing background. We might be doing pickups, etc. And instead of grid, I'm going to rename this to be called tile map grid, just so it's really clear in the future. I'm not saying, what is grid? I'm like, oh, let's do with tile map. Easy. Now, next step, over in the assets folder, we want to right click, create a folder, which I will call tiles. That's where we'll be saving all these tile related things that need to be assets, but we don't need to be playing around with them. So I don't want them to get in the way of my sprites. So in the sprite folder. And also, we're going to click on Window and bring in from 2D the tile palette. I'm going to dock my tile palette just to the left next to my scene. Give myself a little bit of space here. So I've got the palette on the left and the scene on the right. I think we're ready to go. So next step is we want to create a new palette. So click on Create New Palette. I'll call this Platforms Palette. And then click on Create. Where do we want to save that? Well, I'm going to find Assets, and then Tiles, the folder we just created a moment ago. Select that folder. That'll be saved. If we click in Tiles, you see that as a platform palette.prefab. So this is a prefab that we're using as our palette. Our palette is the arrangement of our sprites, of our tiles, that we can then go and scatter around our world as our heart desires. So clicking back on sprites, I'm going to find my SPA rock, grass, water. So in other words, your platforms sprite sheet and open that up and click on the first of those, scroll all the way down, shift click to highlight all of these. So all of these different elements of the sprite sheet, I'm going to drag that over into my tile palette and blump, it'll ask us where we want to save that. Once again, assets, tiles, and that folder, yes, select folder. It'll convert them into assets, which I'll just pop over the tiles directory. You can see all these little assets now. These are individual tile palette.assets, .asset. And we have in our tile palette our particular tiles. Now let's do a little bit of painting over in our window over here. You can see if I click on, say, the top left and place that down, we get a top left tile. If I click on the tile next to that and place it down, I get the next one, and so on. If I want the green ones, maybe I want all of these, I can click and drag across all these and place all of the green ones down and place and place and place, however I want to do it. So you could highlight all of these and plop them down to your heart's content. Not that you would do that because it looks a bit odd, but I just want to show you that if you do that, it'll overwrite exactly those particular squares. So this is not going on top, on top, on top. It's just saying in that particular square, if I click on this left-hand green thingy, it'll say this square, that is what is in that particular square on our particular tile map in this particular occasion. Lots of particulars in there. Now, we can also in here use the erase. So you can see up top right, second from the right, there's the erase brush. Click on that and I can erase certain things in there. Very handy. I can also move by clicking on the move tool and then click on move. This is a little bit trickier, right? You'd think, oh, click on move and then grab and move. You have to do it the other way around. Thank you, tile map. You click on the selection and then you select a particular thing, and then you click on move, and now we can move that particular thing where we want to. So that's a little bit clunky in my opinion, but that is how we click and select and move things. Now, if you have a look, we've got our top left in our tile palette. That's come from our sprite sheet. If I go and pop that in the world and then grab the next two, put that, and like, cool. Now I want to round this off and have the right-hand side, but we don't have the right-hand side in here. So what I could do, a couple of ways, I could click on this top left, pop that in the world, and then click on my selection tool, top left in the tile palette, click back on the tile in my scene. Now we get all of the information in the inspector about that tile. What's it called and where is it? And I can, in the scale, I can select that and turn that to -1. So that's a way of flipping this particular tile on the x-axis. However, you don't really want to do that for this tile and that tile and that tile in your world. You want to have this particular tile you can place anywhere. And we don't have it in our asset pack because the artist is saying, well, I don't need to create this a bazillion times. You've got that one asset there. It's exactly the same. You just flip it. I'll only put one on there so it'll save space on the sprite sheet, but it means we need to do something to create that at the tile palette level. And you know, I just remembered something that I've taken care of because we've gone through this process, but you might be importing stuff that is from a different asset pack or is from the original asset pack. If you click on the sprites, go to the original sprite sheet on the rocks here, we've got to change the pixels per unit to 32. So that means that this particular thing on the sprite sheet, this thing here, we've already created is a 32 by 32. That's the size that it literally is from our sprite sheet, 32 by 32. And that means that when we place it down in the world, it's the right size. If I was to click on my sprite sheet and change this to say 64 now and hit apply, now all of my tiles are going to appear too small. And usually when you bring things into Unity, it starts off at 100 pixels per unit, clicking apply. So everything's way too small. So we've had to make ours 32 because that's the actual size in pixels they are. But if you are working on something, say the original asset pack that I took this from is 16 pixels. So if you're to use the original, you need to set this to 16. I increased the size of these to get a bit more fidelity. I made them 32 by 32 when I did my modifications to them. A quick message from Rick from the future here. If you find that you've got a white line that's appearing between your tiles when you paste them into the world, then sometimes that's fixed by changing pixels per unit to 31, which makes the tiles just a tiny bit bigger and they snap together more nicely and you don't get that issue. So something to play around with. You might want to put pixels per unit to 31. Later on, many videos down the track, I'll be doing that myself to fix the problem I see on my screen, but you might want to just know about that now and be doing that from this point on. Let's come back to what we were doing, which was flipping our assets. That was a random Rick segue. Now I'm going to show you the quicker way to flip things so that you flip them once and you can paint them a gazillion times. I want to make a little bit of space. I want to rearrange my tile palette here. So I'm going to, let's see, show you how to edit in the tile palette. Let's do that. If I highlight these 3, say 4, I want to move them all over to here. How do we do that? Well, first of all, we click the edit button. So select them first, click on edit. Now we click the move tool. Now I can drag that selection over to here to start rearranging. I'm going to click back on the selector tool, grab these top 2, click on the move tool, drag them over, selector tool, these bottom 2 just here that I know are the bottom elements, click on the move tool, drag them on over as well. Now that's great. I want to do the right hand side. So we've got, click on the selector, we've got this left, top left just here. I could paint that and flip it, then paint that and flip it, paint that and flip it. But I'm going to select all 4 of these. The way that I'm going to do that is by clicking on the eyedropper tool, selecting all 4, and now this is what I am using as my brush from my tile palette. I click in the spot I want, just there, to drop them into place. Now I'm going to click on the selector again, select all of these, and then over on the right hand side you see that we've got the grid selection properties. Under scale we've got X, and we'll change that to -1. That flips them all and has it a nice rounded outside edge on it, which is cool. Next up, I'm going to just pop in the middle here the 2 elements that I've got that belong in the middle. I'm going to once again click on them, click on the move tool, drag on over, click on the eyedropper tool, and now I can paint them straight down. So the paintbrush is what we're using to paint. That's on usually automatically by default, but sometimes when you click on the eyedropper, then you select a thing, and then it'll switch over to the paintbrush tool as you see here. Now, if you go back over into your world, it will let you paint things down even when you're in edit mode. But if you come back over here in edit mode and click again, it'll also be painting things down. So I'm going to undo all those things I just did. Click out of edit mode. Now, if you were to paint over in here, you're not going to be able to paint over here, over on the palette. The palette is going to be how you select things once again instead of painting. And then if you jump back over into your scene, then you can paint these things down into the world. So what I'll do is just delete all of my nonsense that I've created just here by clicking on the eraser tool, and I'm still selected on this area that I'd selected on. So you see I get this nice big 4x4 grid that allows me to erase nice and quickly. Next up, what we're going to do is just our very quick paint down a little platformy type thing. That's the last part of our process here. So I want you to go through, do that now as a challenge. Pause the video and take that on. Don't overinvest in this because it's definitely going to change as we put more effort into our gameplay mechanics. But for now, just create a little bit of a level layout. I'm going to do that. You're welcome to watch along. I'm going to speed up the video so that you don't have to watch it in slow time. So let's make our platform. Okay, there we go. You can see if I scroll in here, I've used these nice little curvy roundy bits to make a curvy roundy bit around there. So that corresponds, this one here is corresponding to that bit there, just makes it look nice and curved. But there we go, just a little level just to do some basic platformer stuff. So good stuff. I will see you in the next lecture. Hello and welcome. In this lecture, we're going to be adding some extra layers of tile maps. We're going to be adding the background and the water. So let's get in and talk about tile map and layers. Okay, let's see if you were paying attention in the last lecture. I'm going to ask you if you remember. So this is the challenge for you. Create a new tile map, call it background tile map. Add our background tiles into the palette. Let me just show you which one those are. For me, it's the SPA background with the brown tint, although they're kind of green, so maybe I should rename that, but it's cool for now. Don't worry about it, Rick. On with the challenge. So add the background tiles into the palette and then paint some of those background tiles. And just a note, don't worry if the sorting order or the order sorting is wrong. We'll be going through that together. So if you're finding that your background is on top of the platforms or you can't see it, that's cool. Just find somewhere in your scene and paint down some of the background tiles. There's your challenge. I'll see you back here when you're done. So first thing I'm going to do on the tile map grid, I'm going to right click, 2D object and tile map and rectangular. I want to make sure it's a child underneath our tile map grid, and I will name this background tile map. So if I click on background tile map now, I will be creating to that tile map. If I click on the foreground or the platforms tile map, I'll be creating to that. I can also change it here under active tile map depending which one I want to select. And you see a little boing over there to let us know that we changed something. And so it's really important to get into the frame of mind that if you're doing something on one particular tile map, you've got to switch it, or else before you know it, you've gone and painted a whole bunch of background right over the top of the layer, which is your platform. So just a note on that. Now, what's next on our list? Add our background tiles into the palette. Okay, good. We'll find a little bit of space down below here. We will open up, or I will open up the background, highlight all of these, drag them into our palette, pop them just there, looks good. It'll ask me where I want to put these. Tile folder, perfect, select folder, bing bong bink, brings them all in. And you can see that it doesn't look so good on the screen here, but these are all different tiles with a little bit of random structure to them so that it looks like some background. We've got all that there. Now I need to make sure I'm selected on the background tile map, highlight all of these, and I'm just going to go blink, blink. And as I mentioned before, that doesn't look too good because I'm just painting right over the top of my platforms. I'll pop all these in here now. You don't need to worry for the moment how much space you're taking up. It's just all of the background. You can see where our camera is here with the white part. And if you wanted, incidentally, to make your camera so that you see more, you're like, but that's not enough space to fit in all I want to fit in there, considering that the tile map is this particular size or the tiles are this particular size. You just go click on camera and you could change the size to bring it in. That'll have a lot less tiles on the screen at once, or move it all the way out, and then maybe it makes the tiles really tiny. So I'm going to leave it 5 for now because I'm not sure how big I want it until I get my character in there and have the character running around. But we've found ourselves a bit of a problem. Now let's click on the background tile map, and as we've done before, you can find the sorting order or the order in layer, and I can make the background over in here -1. Boom, there we go. And now it's behind the platforms, and the platforms is going to be at 0. If we click on that, platforms at 0. I'm not going to do it that way because I don't know how many of these layers I want. I'm going to do it a slightly different way, just to show you an alternative way. So I'll put that back to 0. And I'm going to jump up to, in my inspector, you see layer and then default. We will jump into there and we'll click on add layer. Now it's super confusing because we've got sorting layers and then we've got layers. So it's like there's so many layers going on here. I'm going to click on plus on the sorting layers and I'll add a new layer which I will call platforms, and then hit enter, and I'll click plus again and another layer which I'll call background and hit enter again. Now jump back out, click on background tile map, scroll down to where we have our sorting layer and change this to be background. And I'll jump over to my platforms tile map and change this to be platforms. So why did we do that? Well, if we jump back into where we scroll up, look at the layer here, click on the default area, go to add layer, go back to sorting layers, you can see in here, so that's, I know, a little bit of a journey. You can see here if you grab one of these layers, you can move them up or move them down. So we can easily change what is above other things on the screen in a very easy way, because we've got all this layer. So whatever in this list is on the bottom, you will see on top of the screen. I know those words don't make sense. So layer 1 and then layer 2. Layer 1 is background for me, and that is underneath layer 2, which is platform. So if we add a layer 3, 4, 5, 6, 7, we can easily just change what appears over the top of what. Now we can see the result here. I went and made my background very green so it really pops out and you can see it, but it might be too green. Might be looking at it saying, oh, I don't know about that. What we can do, I've just gone and played around with this. That's why my screen looks a little different. If you go into your tiles, find the asset files, so the dot assets that we've gone and created for our tile palette, highlight all of those for the background. Now we've got color. We can do a little bit of tinting on this. So if I click on the color, I might want to have them a little bit darker, a little bit brighter, a little bit more red, a little bit more green, for example. So you can do a little bit of tinting. There's a limitation to this, but if you do find that they're popping out a little bit too much with the greeniness, then you can go and change that. You can do that for any of the tiles that your heart desires. Make them maybe a little bit bluer. Because they're starting off at green, we're pretty much limited to just making them a little bit darker, which is fine. I think that might be enough for us. And you know what, while we're here, just for fun, let's make ourselves a water layer so we can pop some water around in our map. So the water would probably be on top of the background, but underneath the platforms. So go ahead, pause the video and make yourself a water layer. Okay, so once again, tile map, right click, 2D object, tile map, rectangular. We will make this water tile map, and then that gives us that extra option on water tile map. Great. I've already brought this in, so we already have the assets in there. Okay, now we need to, over in the top right on layer, we need to add a layer. We will add in under sorting layers, click plus, we'll add ourselves water. I know it's going to need to sit in between these two layers, and then jump back, clicking on water tile map, scroll down and find sorting layer to be water. Perfect. Now click on some of the water, see if I can paint that down. Yes, I can. And where can I paint it so it makes sense? Not just the air, it'll be floating in the air. I'm going to click on the top little bit of the water. Actually, while I'm here, I'm just going to separate this. So click on selection, select those two, click on edit, click on move, edit them down just so they're not sitting right on top of it. Actually, let's grab that bottom bit and put that underneath. There we go. That's how they go. You know what? While I'm here, I'm going to click on the eyedropper, highlight two of these, and then just paint a couple of things side by side. So if I wanted to paint it down more quickly, I could. So I can click on the eyedropper, select all four of these things, jump back over into the world, and then plop that in, and there we go. We've got some water. It doesn't look that good because I think I need to move this up a little bit. So I'm just going to very, very quickly finesse that, or else it's going to bug me. There we go. Now that we have our little pond in the middle of our platform level with our various layers. So good stuff. I'll see you in the next lecture. In this lecture, we're setting up our rule tile rules, which is going to be super exciting. It's going to allow us to paint things into our world, to use rules to say what tile should be placed in what particular square so that it looks nice and lovely. So let's get started. First step, we need to go to Package Manager and search within the Unity registry. Make sure you're selected on that. It might take a moment for it to think. Yep, and it's cool. Search for tile. If you see in here, tile map extras, that's where we can find the rule tile. I'm going to click install on that. It's kind of hiding over the edge a little bit, the install button. Now in the future, you might not need to install this. It might come standard with Unity. But for now, you need to do that. If you're not finding it, particularly if you're using an older version of Unity, you might need to click on the cog, go to Advanced Project Settings, and enable the pre-release packages. Sometimes when the packages are still having the bugs ironed out of them, you need to go and enable that. But now we've installed that, what I can do is back onto my scene. In my sprites folder, I'm going to right-click and create 2D tiles, and then you'll see now we've got rule tile. Drops a rule tile in here. I'm going to rename that just simply rule tile. I'm just going to have one in my scene, so I don't need to give it anything more fancy than just calling it rule tile. Why have I got this in my sprites folder, not my tiles folder? Well, I'm going to be doing a lot of backwards and forwards with this particular sprite sheet in here, and so I want to have easy access to this rule tile, but in the sprites folder just means things are next to each other, which is handy. Now, I need to actually place the rule tile on my palette so that I can use it in my world. I can't just click on this in my project directory and start trying to paint it around. It needs to be on a palette. And to do that, I'm going to put it on the platforms palette, but you could, if you wanted to, create a new palette that is just the rule tiles palette if you wanted to do that, if you wanted to know exactly where it is. But I find switching between the palettes is a little bit of a pain when you've got a small project like this. So I'm just going to grab the rule tile and drop it right at the top. And it looks like we've got something a little bit buggy that's got introduced into there. That's fine. We won't worry about the bug at the moment. Thank you, Unity, for your bug. But we've got our rule tile, but I dropped it in, but I can't see it. It's not in there. It's invisible. That's because we haven't given it a default sprite. So make sure you clicked on rule tile from down in your directory, and then over on the inspector, you can see we've got this default sprite. You can click the select button, or you can just go to where you know the assets are and find what you want to have as the overall look for this, and the default, if no other rules apply, then apply this one. I'm just going to grab one of my green grass, drop it into that little area there. Now our rule tile has a look to it, and blunk in our palette, you can see that it appears. If I click on the rule tile from the palette, jump over into my scene, anywhere in here, and just paint this down, you can see it's painting that one default tile that I've got. So once again, make sure you're clicked on your rule tile. Over in the inspector, you can see that the tiling rules, the list is empty. This is where we're going to give logic to the rule tile. Click plus. We'll put in our first piece of logic, which will be, let's see, I'm going to find my empty kind of in the middle of things tile, which is this one in here. Also, if I show you on my sprite sheet, it's this just plain color in there. I'm going to click and drag that over the top of the selection, and now you can see everything has changed color. So what do we want to do? Well, we want to have this tile be present when it's surrounded. So my little example in the palette over here, you can see that we've got something on the outside of this one tile just in the middle here. Let me click on that. This tile here, we've got something there, something there, something there, and so on. So over on our rule tiles, you can click in the little grid and you can get an arrow which says, yes, there is something in that space. So you can see the arrows in the top left corner. That means that there would be another adjacent tile in the top left corner. Or you can turn that into an X that says, no, there can't be anything there. If there is no tile there, then this rule becomes valid. So what I'll do is just put an arrow all the way around the outside. Later on, we'll see that we don't need these corner ones, but for now, let's do what makes sense. And it says, if there's something surrounding this tile, then hey presto, this is the tile that it becomes. Just click back on the rule tile. And if I go and paint up the top here, you can see it's magically changing what happens. It's saying, oh, I think you want to have this particular tile based upon your rules. Okay, let's set up another thing. We'll do the corner. We'll do the top left corner, which corresponds to this particular tile up here. You can see we've got the corner in the top left is different to the corner in the bottom left. You could just do the same, but this top, the bit you jump on looks a little bit different. It's a bit more faded down the bottom. So we've got a top left and a bottom left. We've got these side ones, got the top ones, and all these ones here that have a solid edge on the left and the right is when you just have a single tile poking up in the air. Likewise, these ones are when you just have a single tile poking left and right. So let's click on plus, add a new rule, and this new rule, what do we want the tile to be? Well, let's find the very first one here, the top left corner, drag that on over. What are the rules for the top left corner? Let's have a think about that. So this top left corner here, there's no tile there. There's no tile there. That's a little bit misleading as my cursor pretends there's a tile. Let me click on something that's not a tile. There we go. Nothing there, nothing there, nothing there. So let's go and put an X in the top left, an X right above, and an X right to the left of it, or left to the right of it. And then we do have a tile to the right, a tile to the bottom right, and a tile below. So we'll put a arrow, an arrow, an arrow. Now, there's not a tile here, but there might be. So in that instance, we'll leave it blank, because I'm not sure yet. Maybe if we were to paint a tile there, we still want this to be a corner. So if it's doesn't matter whether there's a tile here or not, then you just leave it blank, as I've done there. Click back on the rule tile, make sure this works. Okay, yeah, you can see as I paint one there, it currently doesn't have a tile to the right of it. That's why it's staying in that default shape. But as soon as I put a tile to the right, the rules apply. You've got nothing left, 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 and you've got something right, right, right. So the right and the bottom. Now, something cool that we can do here, instead of having to go through our whole flippy sequence we did last time, which, side note, it seems to have broken itself. I'm not sure why. Might need to go in and reapply that because it's misbehaving, but I don't need to do that at the moment. We're going to transition to rule tiles for most of this. What we can do over here and say, well, this same rule I want to apply if this is in the top right as well. So I can click on the rotation. So right in the middle, you see there's a little gray symbol. It's a dot, then it goes to a curved arrow, a lefty right arrow, an uppy downy arrow, and then the uppy downy and lefty right together. So the dot means just keep it as is. The curve arrow means rotate. That means rotate 90 degrees, 90 degrees. So to do that the entire way around. Now you can see by doing that, we've got top left. Just click off this again. Top left is a corner. Top right is a corner. Also, if we go down the bottom here, you can see bottom left is a corner and bottom right is a corner. So that's what happens when you rotate it. You can get all this power just by adding one tile. You don't need to add all these rules all over again because it's rotating what the rules are as well. Now, I don't want it to apply to the bottom left and bottom right because we've got this bottom corner. So in this instance, I'm going to do just a mirror on the x-axis. If I was to click it again, it'd be mirror on the y-axis. Click it again, it'd be mirror on the x and the y, and back to the dot. So just on the x-axis, that means it's applying to the top of our corners. Now let's apply the bottom. So click on the plus again, add, and then we will find what is the bottom left. I think this is the bottom left corner just here, looking like that. So just a reminder, it's that one just there you're looking for from your tile set. If you're using the same tile set as me, that is. Drag that on over. Now I will say what the rules are. Once again, we'll hop in here and find it. Well, there's nothing in these bottom pieces. So X, X, X. And then there is in the ones adjacent to it in the top right, and right. That should make our corners. Yep. And then we'll do mirror on the X once again. That means over there it should be valid. If I jump in and just click on the rule tile, do a little bit of painting around, yeah, it looks like it's all behaving itself pretty well. What's not behaving itself well just yet is you can see our bottom is not working, so we need to be applying the bottom tile. Our right isn't working, our left isn't working, and our top is... Well, it's kind of working, but not the way we want it to, because it's just applying this green single square. And I think I might want to have a little bit of random, so it's sometimes green and sometimes blue, because I've got both of those tiles in my tile set when we've just got this long flat platform. Let's see if we can figure that out, how to do some randomness. So we'll click plus again. I want to add a tile. This time we will change from output from single to random. And in random, how many of these do we have? We've got 1, 2, 3 green pieces, and we've got 1, 2 of the blue pieces. So I'm going to change this to be 5 in terms of how many things we have. And you can see when we put it in there, it's got a whole bunch of blank spaces because it's randomly choosing between this rock and nothing. So let's go and grab in our other sprites, the other green sprites, 1, 2, 3, and then the couple of blue sprites, 1 and 2. Now they should all be filled in. So sometimes they're going to be green, sometimes they're going to be blue. You can do a little bit of additional randomness. So we could mirror on the X, which will make these tiles flip, which is kind of interesting to do. You can mirror them on the Y, which you don't really want to do. It makes them upside down. But if you wanted to get a whole bunch of additional randomness and variability in there, that's a cool thing to do. So we've got that. Our tiles are being placed in. Let's just see if we can draw a bunch and see if we get this randomness. Random. Yep, so we've got a little bit random there. Green, blue, blue, green, green, blue. Because we've got 3 greens and 2 blues, there'll be a little bit more green. But that's okay. There's a little bit of grass growing in our world, and it's happening in a random way, which I quite like. Now we need the rules for this. Okay, so what's the rule? Well, when it's a top tile, there'll definitely be nothing right above it, so an X there. There is going to be something below it. So that's pretty much all we need for the tiles. Now, is there something to the left? Maybe something to the left there, maybe. Not sure yet. We'll figure that out as we go, as we add in more tiles. You can see it's a little bit broken over here, so maybe we do need to add something saying that, yes, there's something to the left, yes, there's something to the right. Okay, it's nearly there. Oh, we don't have our side pieces yet. That's why it's looking a little bit funky. Our default piece is that grass. That's why it's looking a little bit weird. But we're making good progress, and we've still got a bunch more rules to set up, so I'm going to give this to you as a challenge to finish your rule tiles. Finish setting up your rule tiles so that all the shapes and positions work and look good. And using your rule tile, just create a couple of simple platformer layouts, just a couple of jumps and a couple of gaps to jump over to show that it all works. Maybe some single things up in the air. What do I mean by that? They're the tricky ones. So a couple of these single things and a couple of single sideways things as well to make sure you get the top and the bottom on that. And just one quick thing before we start our challenge, the order that things appear in the list is the priority that they're given. So whatever it is at the top will be the rule that's enacted first. So if you find that things aren't quite lining up, try dragging things up and down in the order just to see if that changes it. Putting it as a higher priority might fix whatever troubles you're having. Okay, so jump into the challenge. See you back here when you're done. Okay, welcome back. I've gone ahead and created all my rule tiles. Now, what I've found in the past is that people say to me, Rick, you went so quick through the rule tiles. What were they? How did you do them? And so what I've done is created a little screenshot here of my rule tile rules. I've given this to you as a JPEG, so this particular image here, so you can go through and see exactly what I've done. You can see what the rule tiles are. If you're wanting to do this just on the video, then I'll hold it on that bit. You can pause, and then we'll go down to this bit. You can pause and have a look at that and check what I've done. And then I'll jump down here and you can pause again. I think that captures it all. Just to note, there's a couple of places where you don't have to do randomness, but I did. So I did some randomness on, on our flat. With the grass top. We talked about that already in the video. I did some randomness on the bottom, randomness on the left, because these are things that I had multiple assets for. So I just dropped those in so that we could do that. And also a little bit of randomness on the overall tile here, the middle tile in the middle. I just randomized between the straight up solid color and the solid color with the bumps on it. If you play around with the noise, that just changes where the randomness appears. You can get some different looks. If you're like, oh, that look wasn't quite right for me, then you can play around with the noise to get some different looks there. Some other things I'll note is that I needed to drag up to the top. Let me get my image back for you so it's easier to see. Needed to drag all the way up to the top. This corner piece, I found that made the most sense in terms of having that rounded corner piece actually show up. That corner piece, I mean, is this one just in here, this rounded edge piece in here. I had to do a lot of drawing what happens when I go up like that, because there's a whole bunch of these rules for if you have something just sitting on its own. You can see this is the sitting on its own. There's X's all around the outside. What happens if something is just sticking out from the side like that? That's this piece just here with the X's and the arrow. I've mirrored on the X-axis for these ones so that you see the same thing appears when we have it over on the right. Also, what happens if we have something sticking out of the top? That's this one here. And similarly, if we have just a pillar rising up in the air, that is that one here as well. Likewise, the pillar on the horizontal. So I've got those things there. The one that I've got right down the bottom is this kind of middle padding stuff. Once you make a box all the way around the outside, then this one right in the middle here is going to be the catch-all rule to catch them right down the bottom. I think that's most of what I did in terms of the changes. A couple of little tweaks. I put in this piece here, which is has the solid top, then just a couple of dots, because I was finding there are a couple of places where we needed that. Where did that show up? Oh, there we go. This is this bit over here. So when I have just that little square and there's nothing above it, there's something to the right, there's something to the left, something below, then I needed to have this particular tile in there. If I didn't have that, then it went a little bit weird. Or if that was dragged all the way down to the bottom, then it just placed in that weird, just straight up flat tile at the top. So I put this all the way second from the top. Now that gives that priority over our other rule, which is just our flat top platform rule. So there we go. That's all my rules. I'll give you that as a downloadable so you can see the image. You can also go to our repo for any of our lectures, just a reminder, and you can go and download or grab or clone this specific commit that I've made where I'll have all of my rules. So hopefully you found that a fun experience. I love the fact that we can just slap down our platforms however we like, and I will see you in the next lecture. In this lecture, we're going to make our screen even busier. We're going to add our animator controller in our animator window here and give our player a little idle animation. I'm going to quickly tidy up all the nonsense I've got splashed around in my level here. I'm going to drag a big old space, click on the eraser tool, and then just clear out all of my playing around I was doing with my rule tiles. Also, I was being a bit fast and loose, and if you note here, my active tile map is the water tile map, so I was drawing all those platforms on the water tile map. We should be drawing this on the platforms tile map. What I'm going to do is click on that, then click on my rule tile, and then just paint directly over the top of what I've got here already. Bip bop boop, balum ba ding. Now I've replaced all of those tiles with my rule tiles so that if I go and add some new stuff in here, then it knows what's going on. So I've just updated it there with rule tile information. Now what we're going to do is create our player idle animation. We need to first of all start with window and then find animation and find the animator window. I'll just grab that and pop that down the bottom, I think, next to my project and console. And I'm going to be throwing a couple of terminologies here. If you're not familiar with animation in Unity, then it could seem like I'm saying the same thing over and over, but let's have a look at the terminology. First of all, we have the animator component. This is a component that we put on our game object. We'll pop this on our player, and this is what assigns animations to the game object, which will be our player, through an animator controller. What's the animator controller? Well, this is the arrangement of animations and transitions. This is the state machine that says go from running to jumping to idle to shot to whatever it might be. That's the animator controller that controls the animations. And the animations are the specific pieces of motion. It says show this frame, then that frame, then that frame, or move this to that. And we also need to have a sprite renderer so we can display the 2D sprite on the screen, actually visualize it. Now the steps we'll go through to set up our character's idle, and I'll list these out as a challenge in case you've done this before. We talk about animations in a couple of our Unity courses. A side note, make sure you check out all of the Game Dev TV Unity courses so that you can get the full experience and you can educate yourself to the absolute max. But here's the challenge if you've already done animations in the past. Import the sprite sheet and slice. We've done that already a couple of lectures ago, so we've got a head start already. Add the sprite renderer to the player. We'll do that in a moment. Create idle animation clip. So in other words, find the player sprite sheet and find the specific sprites that look like they're the animation, just kind of standing on the spot, popping up and down. And then create a character animator controller. Add the idle animation to the animator controller. So we've got that in there. And then add the animation to the player so that the player can stand there and bounce on the spot. Finally, assign the character animator controller to the player. So there are the steps. Feel free to come back to this in the future. If you want to take this on as a challenge, do so now. If you look at this and you say, what's going on here, then no worries, we will do this together, which we'll jump into now. As a first step, let's make ourselves a player. Right click in the hierarchy, create empty. I will call this, shall I call it something silly? Yeah, we'll call him Ginger. And in brackets, the player, just in case you're more old school and you're like, you called the player, Rick. What are you doing calling him, giving him a crazy name, Ginger? I'm going to reset the transform. That's great to make sure we haven't gone and put it way off in some sort of weird Z position. It's going to be 0, 0, 0. And next, we'll add a component. The first component we need here is the animator. And note here that it's looking for a controller. What is the animator controller? In other words, what's the thing that's going to tell me what to do, to tell the component what to do? So that is something we set up in our project. It's going to be an actual asset we have in here. So I will go into my assets directory, right-click, create a new folder, which I'll call animations, where we will pop all things animation related. Open that up, right-click in here, create. Let's find animator controller, and we'll rename this to be player. If I double click on that, open that up, you'll see that we've got a couple of things in here already. You can zoom around, you can use the middle mouse button as we've done in other things. Move this. This is a state. It's the state of exit, which basically means get out of this animation or get out of this entire animator controller. The entry point, this is where we're entering into, and just another thing, any state. So that could be if you want to have some rules that say whether you're jumping or running or swimming or snorkeling, whatever it might be, you can do a particular thing from a particular state. So we'll get into this again in a moment. Just wanted to give you a quick look-see at it. But for now, what we need to do is create an animation. So back onto project, we'll find ourselves our player sprite sheet. So for me, it's the SPA player Ginger. Why is he called Ginger? Well, I gave him red hair and I thought Ginger, maybe his name should be Red, actually. That'd be a smarter name. But anyway, we live with our choices in life, don't we? So that's fine. I'm going to pull up the little preview window thing. We can sometimes forget about that, but there it is there, our preview. Let's see if we can find things that look like idle. That looks like a roll. That looks like a climb. That looks like a bit of a bounce. That's a run. I think it's going to be somewhere around here. So 5, 6, 7, 8. So you can see there's a number of individual sprites, individual images that have been drawn, and when you play them together, obviously I'm just scrolling backwards and forwards here on my keyboard to show you these, but it looks like a little bit of a bouncy bounce on the spot. So it's going to be from 5 through to 8 in this particular tile set, and I'm going to highlight all of those. I'm holding down Shift and using my keyboard, or you can do Shift and your mouse, and I'm going to, while these are selected, I will right click, create, and look for animation. Boink. There we go. It's called new animation. We'll call this idle because that's what he's doing. He's idling. And this is living at the moment, this .anim file, which is basically saying go through frame 5, then 6, then 7, then 8, 5, then 6, and 7, and 8. Grab that, and we're going to put that into our animations folder. Back to our animations folder, you can see that we've got our idle, and we've got our player animator controller, idle animation. And you know what I want to do is drag this into my animator. So I'll just grab the animator and dock it over to the right here so we can see our files and we can see the animator at the same time. So you can see what I'm doing, which is grabbing the idle animation, dragging that idle animation, which consists of our 4 frames of idle, and just dropping it into our animator controller that is now added as the state of idle. And you can see the little line here is saying a transition. Basically, as soon as anything says, hey, use the animator controller, which will happen when Ginger, our player, is instantiated in the world, to say, right, do the animation, straight from the entry point, go immediately into idle. Now, if we click on idle, we can see a couple of things here. You can change the speed. If you think he's bobbling up and down too quick, you can make it slower or faster by changing the speed here. Actually, what I will show you for completeness is let's go to Window, find Animation, and then find Animation. This will be the animation window. If you haven't done much animation, then you might be wondering, what is the animation? What does that all mean? Well, if we click on idle animation, then our animation window will show what's going on here. You see there's 4 frames in here, 1, 2, 3, 4. And if we open up the information on sprite, you can see that the sprite that we put in here, it'll show us that first one. So there's sprite 5, sprite 6, sprite 7, and sprite 8. And it's added those in here. And when we push play, it's going to go blink, 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 and then loop back to the start, blink, 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 loop back to the start. So that's how our animation is going. So when we created our animation by highlighting those 4 sprites and said, turn it into an animation, this is what it just did. It said, on the first frame, put the first thing, on the second frame, put the second thing, and so on. So back to the animator window, we've got our idle in there. Next up, what we need to do is to tell our player, so click on player, to tell it to use the animator controller that we've just set up, the rules for the animation, if you will. So click on the little selector. There's only one in our scene, player, double click on that. That will assign the player animator controller. Now, to be able to see our character on the screen, we need to do what? We need to add a sprite renderer. So click on Add Component, search for Sprite, and then add in the Sprite Renderer. Now we need something to see on our screen. So at the moment where we have Sprite as none, we need to put a particular sprite in there that we can see. Let's click on that and select just any of our sprites here. This is not going to be what the player sees. This is just a representation. So I'll choose what I think is the first idle animation. Seems okay. Now that should be somewhere in our world, but where is it? If we click on player, it's missing. Little bit of a micro challenge for you here. See if you can figure out what's going on and fix that. Well, if you guessed that it's hiding somewhere underneath all of these layers, you got it right. And because we've set up our sorting layers, let's go and add a sorting layer for the player. So I'm going to jump all the way up to default layer where it says layer default, add layer. We will add in a new sorting layer, which we'll be clicking on plus. We'll call this player. Hit enter. Now back to clicking on the player and scrolling down to where we see sort layer, and I'll change this from default to player. Actually, you know what I need to do is make sure it's in the right spot. So back to add layer in here, go to sorting layers, and let's see, the player needs to be probably on top of everything, to be honest. There might be a little bit of being underneath the platforms. Yeah, I think if the player is the very last layer here, then it should be over the top of everything. So let's have a look at that. Click on the player, drag the player on over. Yeah, now the player is going to bounce around over the platforms. Okay, so the moment of truth, if we click on play, find our game window in here. Is our camera set up? It should be looking at the character. Nothing happens. Well, if we look down at our animator, you can see this blue line is just stopped. But basically, I think what's happened is it's gone through all four of those sprites, bump, very quickly, and then it stopped. So now what we need to do is find our idle animation, click on that, look over in the inspector, you can see loop time, click on loop time. That will just say loop our animation or loop our frames over and over and over. Now when we click on play, he should be doing his little bounce. There he is, doing his idle. Excellent. So there we go. We've set ourselves up the starting point of our player, just a little idle animation. And because we've created our animator controller, we can now add other states in here, such as running and jumping and climbing ladder. So good start on animations. I'll see you in the next lecture. Hello again. In this lecture, we're setting up some more states. So our player can run when we're in that state, and our player can climb when the player is in that state. Let's get started. Let's start by having a look at our sprite sheet. Just here, if I click on the sprite sheet and then click on sprite editor, it will zoom me in and allow me to see what's going on. If we click on this bottom left here, I believe this is going to be our run animation along the bottom here. Run, 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 run. Yep, with a little bit of a bobble as he goes. And this is from number 19, so frame 19 or sprite 19, all the way up to sprite 28. Close out of our sprite editor, find our sprite sheet, open that up, and then look down for, let's see, where is 19? Over on the right-hand side here, I've got my preview, so I can see the number. That's going to be 19 from there. So find 19, scroll all the way down the end of our player sprite, highlight by holding Shift and then left click. Then I'll right click, create animation. This animation I'll call running, because that's what we're doing. We are running in that animation. I'm going to pop that into the animation folder, open up the animation folder, now drag running into our animator controller. We have running in there. Doesn't matter where you put these things, it's all just representational. It doesn't matter the exact layout, but I'm going to put my running just there underneath my idle. Now we need to tell our system when to go from idle to running, and we need to give it a transition. And a transition says this is you transitioning from one state to another. So if you click on idle with your left click and then right click, make transition, it brings up our little arrowy thing here. Drag that over the top of running and it will snap. Click to pop it on top of running. Now if you click on the arrow itself, you get some additional information. We've got in here, I'm just going to push the preview down. I've got in here a little bit of blending. That means to blend from one animation to another. We don't need to do that because when the player pushes an arrow key, we want our character to respond immediately and do the run animation, not to have a little bit of, I'm still idling for a while. And that's what's happening here, idling from one state to another. So I'm going to open up settings and just put the transition duration down to 0. I'm also going to put the exit time down to 0. And while we're here, I'm going to turn off has exit time. What does has exit time mean? Well, normally we would use that if we wanted to trigger a one-shot animation. Say you pushed a button and the player did a little jump for joy and then returned, and after that animation had finished playing, it just went back to idle. Then you can say has exit time, which is basically a cool way of us saying play the entire animation and then just go back to where you came, or finish doing the animation, we're done. We're not going to use that because we want to say if you're you're holding down the controller, keep running, keep running, keep running. If you're standing on a ladder, then stay in the ladder animation. If you're standing on the spot, just do idle. So we're going to turn off has exit time. And you see when we do that, it says we've got a little warning. Transition needs at least one condition. We don't have a condition at the moment, so let's make a condition that says, well, when is it that you transition from idle to running? So if you click on your animator window, it's probably by default on the Layers tab. There's another tab here, Parameters. We're going to click the plus button, and then we've got a few options here for the type of parameter that we'll use as a condition. We're going to select bool. Bool is going to be true or false, so we're going to call this is running. Because is running is either true, that means you're running, or it's false, that means you're not running. So is running. And then over in the conditions, we'll click plus. By default, is running is populated in there, and is running is true. That means if we're running, go into the running state. Now I'm going to click on the running animation again, right click, make transition back to idle. Actually, while I'm here, I'm going to click on idle, and I'm going to change the name of this to idling, because I'm idling, I'm running, I'm climbing. So we'll use that naming convention in here. It doesn't matter a great deal, but I like to have these things match up. I'm going to click on this transition line, set my duration down to 0 once again, exit time to 0 once again, and turn off has exit time. Click on the criteria here. Just a little challenge for you. What do we need to set this to? Well, is running needs to be false. The other thing I'll do while I'm here, click on running animation, and we need to make sure we have loop time. So it loops over and over and over and doesn't just play one time. Now, if we click on play, that'll take us to the game window. I'm just going to click back on the scene window because I can zoom in a little bit closer. It makes it easier to see what's going on. And in our parameters, if I click this checkbox, we should go into our running animation. And this is what we'll be doing in code. Now we can just click it manually, click it on and click it off, and that will change from one state to another. So it should change from running to idling when we're clicking on that. This is what we'll be doing in our code in upcoming lectures, which is going to be really cool. We can visualize it here. Now, if you find your running's a little bit slow, which I kind of am finding in here, then we can hop out of play mode. We can go over to running animation. We can go to the running state, and we can change the speed to say, 1.5. Click on play. I might be able to do that in play mode, actually, and keep the changes. Then click on, just back to scene again. Click on running, run. That seems like a little bit more of a brisk run, doesn't it? That's pretty good. If we change this, let me just do a little experiment. While I'm in play mode, hop out of play mode. It does retain that change that we make, which is cool, 1.5. As you know, a lot of things don't retain, but this seems to be retained. Now, next up, we're going to implement our ladder climb. So back over to our sprites, we'll find our sprite sheet. Click on Sprite Editor, have a look at what's going on. It's going to be these two just here, blop, blop, blop. And they are 14 and 15 that we'll be implementing. So it's frame 14 and 15 we'll be setting up, and I want you to do this as a challenge to implement climbing animation state, create a transition from idling to climbing, that's important, and create a trigger for the climbing state that we can test it and go about doing your testing. So pause the video, take that on, I'll see you back here when you're done. Okay, first step, we'll go into, I've forgotten the numbers I selected already on here. It was 14 and 15. So we'll find 14 and 15. I didn't do anything there. 14 and 15. Sounded like I was in trouble, didn't it? I didn't do anything. Don't make the change. Highlight both of those, right click, create animation. We'll call this animation climbing. We'll drag climbing over into animations. From animation folder, we'll drag climbing into our animator controller, pop it over to the right here because I want this coming off idling as well. We're going to go, if we stop running then and we start climbing, we'll transition through idling to do that. We don't need to go directly from running to climbing. It'll just be not running, okay, am climbing. That's the logic I'm going to use here. So right click, make transition over to climbing. While I'm here, right click, make transition back to idling. I'm going to create my parameter while I'm here, which will be a bool. We'll call this is climbing. Now we'll click on the from idle to climbing. Change our settings in here down to 0, turn this guy down to 0, turn that guy off. We'll add our condition, which will be is climbing, is true, yes. Now on the way back again, we will drop the transition, doesn't have an exit time, and we will click plus and is climbing is false. Okay, now I'm just going to unclick my running checkbox here, click on play to test out to see if climbing works. Not doing anything at the moment, just idling, hanging out, chilling. Click on is climbing, beep, beep, beep. Okay, I forgot to do looping. So click on our climbing animation, click on looping. I think I've forgotten to do looping for every single animation I've done so far in this section of the course. Click on scene, climbing, beep, beep, beep. Oh, that's really fast. Maybe a little bit too fast. So I'm just going to quickly turn the climbing down to say 0.8. It's 0.75 maybe. It's too fast because we've only got the 2 frames. So it's just flicking between those two. That's fine. And we need to have a way of saying when you're stopped, stay in this state, but don't actually play the animation. We'll play around with that later on because we don't want a player stopped on the ladder and being like, like that. We'll figure that out later on. So now we've got our running state and our climbing state. Misbehaves a little bit if you click them both at the same time, but in our code logic, we won't let the player do that. You'll be doing one or the other. So there we go. We've got some cool animation states that will allow us to have our character come to life when we actually start moving it around on the screen. So great work in this lecture. I will see you in the next one. In this lecture, we're going to have a little bit of a play around with prefabs. Now, prefabs are a really important concept. We haven't got to them yet because we haven't really needed them, but now we're going to start creating content for our game. It's going to be very important that we know how prefabs work. So what are prefabs? Prefabs are game objects which we've turned into reusable templates. And the original template is called the prefab, and the copies we add into our scene are called instances, and we'll play around with both of those in a moment. And turning a game object into a prefab means a lot of things, but one important thing it means is we can easily load that prefab into any scene in our game. And in this particular section of the course, we're going to be loading from one scene to the next. So it's important that we are able to persist certain things so we can have a player that goes from scene 1 to scene 2 to scene 3, etc. And we need a prefab to be able to do that. The challenge throughout this lecture is very simple. We won't be saving our work in this lecture, so be sure to have fun experimenting with prefabs as I'm explaining them. That's the challenge. Play around with them. If you've already seen prefabs before, it's cool. This should be a pretty easy process. But if you haven't seen them before, make sure you're comfortable, that you understand, oh, that's how prefabs work, as I'm experimenting and showing you what's going on. So just a reminder, we're not going to be saving our work here. It's all just to get a concept. In the next lecture, we'll start actually prefabbing things in our game. So over in the hierarchy, let's right click and create ourselves something. It doesn't really matter what. We'll make a 2D object, sprite, and we'll do a circle behind all of our content. So I'm going to drag it over to the left over here. Like I said, we're not saving anything, so it's fine for us just to play around with things. We've got ourselves a white circle. Now, up until now, we haven't needed a lot of white circles or things like white circles. So all we've been doing is Control D to duplicate. Now we've got a second white circle, maybe one more. Okay, there, we've got 3 circles. That's all I wanted to do. Easy. But what if, here we go, what if I clicked on the first one and said, actually, I want my circles to be bigger and green. So I go and change the color to green. That looks nice and a little bit bigger. So I'm going to scale it up. Click on the R tool. Scale it up. Great. Oh, but now I need my other one. So what can I do? Well, I could delete these. Delete. And then click on this again. Duplicate. W. Move it over. Duplicate again. There we go. Okay, it's all good. But that wasn't quite in the right position it was before. That's a pain. Okay, well, if I made a change, then I could go and put that information back onto here. So if I change this one to say red, then I could go and click on this one and make it red or orange, I guess that turned out to be as well, and so on. You get the point. It's a real pain. But that's cool. It's all we've needed to do up until now. So let's talk about prefabs. We'll take one of these circles. I'll take the original one. I think, there we go, circle. Now to turn this into a prefab is really easy. All I need to do is grab the circle from my hierarchy, drag it down into my project folder, anywhere we like, and there we go. This is now officially a prefab. That process of dragging it in there made it prefab. You can see now it's blue and it's changed the icon. That now is clearly a prefab, or it's a prefabbed game object. This is the prefab down here, and you can see it's circle.prefab. This has created a brand new thing that is saved on our hard drive. So if I was to right click, show in Explorer, you can see in here we've got a whole bunch of things. We've got our folders, animation, scene, sprite, etc. And we've got this circle.prefab. So that is now something that lives on our hard drive. If I was to delete it from here, it would delete from there. Everything else we put into our scene, so if I go to scenes and look at that, you can see we've got our sample scene. If I was to go and change something in here, so if I was just to add another circle or maybe a, let's see, a square, doink, and just save it without making it a prefab, then the place that is being saved is within our scene, our sample scene that we've got at the moment. So all of this information is saved in there, which is okay, but not as good. We want to be saving our important objects in a separate place so we can use it in many places. We can use it from scene to scene. Okay, so that's just the fundamental structure. I'm going to get rid of the square. Fundamental structure of saving it as a prefab. Now what can I do? Well, I can go drag, boom, we've got a whole bunch of circles in our scene. And you can see it drops them into the hierarchy. They're all blue. these are all instances. So as I mentioned before, these are instances of the prefab. The original prefab is not that one there. That is now an instance itself. It's the original instance, if you will. It's the game object that we turn into a prefab, but the actual prefab is just here, sitting down in the folder, saved as a prefab on our hard drive. This is just an instance of that prefab. Now, say we want to make a change. So I get there and say, orange, what was I thinking? What are you thinking, Rick? Crazy. No one wants orange nowadays in their video games. They want yellow. I changed that one to yellow. It doesn't matter which of these instances we change. I changed circle to. Let me just group these down here so they're together, or else it's going to freak me out a little bit. There we go. They're all nice and together. And put that down there just so my OCD is all fine. We've got our 4 circles, and one of them, let's see this one here, click on it, circle 2, is yellow. What I can do to have all of my circles now become yellow is up in the top right-hand corner on the inspector, you see overrides. That's part of the prefab. It says prefab open, prefab select, and then overrides. Overrides, you can see that there's one change we've made, which is part of the sprite renderer. The sprite renderer is where we change the color. If I click apply all, blunk, now all of my instances are yellow. It applied back to the prefab, and if it's on the prefab, then the change propagates out into the instances. Now, what if I clicked on this and changed the scale a little bit? So hit R and scale it up. Okay, and then go to overrides and apply all. Boom, they all change on the scale as well. There's another way I could do this is by working directly on the prefab. So if I double click on the prefab in my folder, that opens up the fresh prefab sitting all on its own, nothing else to distract us. And if I was to make a change within here, say I changed it to green now, you can see the prefab has been changed to green. Up in the top left, a little bit hard to find this one, but in the hierarchy, there's a little chevron arrow thing next to where it says circle. If you click on that, it'll take us back to the scene view. We're no longer editing within inside the prefab, and you can see it's made the change. I don't have to go into that view. I could click on the prefab circle and then change the color to a blue color, and you can see that's going to change it all on the fly. I like this because then I can see other instances in our scene are changed as well at the time that I'm changing the prefab. One last place that we can click into the prefab, you see this little arrow thing next to my instance. If I click on that arrow, I'm now editing the prefab. I'm editing this guy down in here, and any changes I make to this particular instance is actually this particular prefab. So once again, if I go and change the color to something else, it propagates. But this is a nice way of looking at it because I can see them all within context. If I double click on here, onto the prefab, it's not necessarily going to show me all of those in context. I click back out on here, I'm back into the scene, and you can tell if you're in the scene or in the prefab. I'll just click back into the prefab by what you see over here in the hierarchy. I don't see anything else, but what I see up the top here is circle. And then if I click back, then you can see now it's showing me I'm on the sample scene. It doesn't have that circle on there as it did before. Now, one other important thing I want to show you here is, say I go and change one of my instances, circle 3. Let's go and change circle 3 to, I don't know, we'll make it purple. I haven't had that yet. Purple, that's great. I don't want that to stay purple. But, you know what? I want all of my other instances to be a different color. So now if I go and click on the prefab and change the other instances to more of a red, they changed, but the purple one didn't. Why is that? Well, if you've made a change to the instance that's different to the prefab, when you go and make a change to the prefab, it doesn't override that change that you've just made. So I could change the scale, I could change color. I don't have a lot of other things on this particular object at the moment, but any of the components this same logic applies to, that by making these changes, I've gone and changed the scale. And from this point on, if I go and change anything on the prefab, the X scale, it's not going to change the X scale on my instance that I went and made a modification on that X scale. However, if I was to go and change the Y scale, like that, they all change on the Y scale because I hadn't gone and made a change to the instance. Okay, hopefully that makes sense. If we change something on the instance, then making a change on that same particular thing on the prefab is not going to change the instance or roll out. And it's a lot easier to see on the light theme than it is on the dark theme, but anytime you've changed something on the instance that's different to the prefab, it bolds the particular element. So here, color is bolded. I know it's hard to see, and our X value is bolded as well. If I look at it and say, well, I really do believe that the color is the best color, but I don't actually want to change the scale, then I can go up to overrides and choose a particular thing. What was it? Yeah, the sprite renderer, that's the one I want to apply. That's what the prefab has. That's what I've got on my instance, and I can click apply and apply that. and all of them will be purple, but we keep the scaling that they've all got on the particular objects. And the other thing to mention in here is that we're dragging these in. This is called instantiating our object, or instantiating our prefab. So here's a prefab, I'm instantiating it. That creates an instance. We can also instantiate in our code, and that's something we'll do later on in this section where we'll say, write some code that says instantiate a thing, and boom, it appears on our screen. So that's another good use for prefab. So just to summarize then, prefabs are great. It allows us to have a lot of objects in our scene, but it's all coming from one object. So it's an efficient way of creating things. It allows us to make changes to one game object on a prefab. For example, change the color, and then that will propagate to all the other things in our scene that's an instance of that prefab. It allows us to load things from scene to scene. If we're on the next level or the next scene, we can easily add new circles to that next scene without having to create it from scratch. We've got this template that we can work from. So prefabs are a really fundamental aspect of Unity, very important. And from this point on, we'll be using prefabs a lot more freely. So good stuff in this lecture. I hope you had a good chance to experiment, and I'll see you in the next lecture. In this lecture, we're adding collision to our world and collision to our characters so that we can drop to the ground using gravity, boop, and then stand there and not fall over. So let's jump in and get started. I think it's time for us to prefab our player, so I'm going to jump in my assets directory, right-click, create a folder, and we will name this prefabs. It's good to have all these things as prefabs, because if we want the player to go from level to level, we need to have one player prefab that we're using. So I'm going to open up prefabs folder, grab my player, just drop the player down here, makes a prefab. Excellent. Now, because we're going to be making some changes to the player as well in this video, so make sure you pay attention to whether you're working on the prefab or working on the instance or what you're working on, just a note of that. Now, let's turn our attention to the tile map itself. We want to add some collision on there. There's a couple of nifty things we can do, but first of all, just a note that we can apply the collision to any of our particular tile maps. So we've actually got 3 tile maps in our scene at the moment. You can see we can change it by either selecting along here, or we can click on the object in the hierarchy itself. So we want to be putting the collision on platforms. So when the player is touching these platforms, the player lands on them and can jump on them, etc. Not on the background and not on the water. Well, maybe the water, but probably not for the moment, but definitely on the platform tile map. So while we've got that clicked in our inspector, I'm going to scroll down, add component. I'm going to start by adding a tile map collider 2D. And that, you see, will add collision into all of our blocks, all of our tiles that we've placed in the scene. That's a good start. We could potentially finish at this, but there's one issue that I found is if you scroll all the way in, all the way in, all the way in, we'll see how far it's actually going to let me scroll in here, all the way in. You can see that there's a gap, well, you can't see, but there is a gap between this tile on the left and this tile on the right. The collision, there's this tiny little gap in there, and sometimes we trip on it. We get our foot stuck in it and things don't go so well. But there's a cool thing that tilemap lets us do. If we jump down into add component again, if we search for Composite Collider 2D, that allows us to join all these things together. So when we added the Composite Collider component, it's also added a rigid body. All we need to do here is set this to static, because our world is not going to move. It's going to stay where it is, the platforms. In the future, we might do some moving platforms, in which case we wouldn't do it as static. But for now, all we're doing is just having it sitting there stationary, make it static, and then I'm just going to roll up rigid body 2D so it's not getting in the way. Under Tile Map Collider 2D, you can see that we've got a used by composite. If we click on that, then our entire world is wrapped. Our tile map is wrapped with our collision. I'm just going to turn off for a moment the tile map renderer, just so you can see we've got this green outline now that is our collision that goes around all of our tiles. And if we were to get there and paint using our rule tile, paint a new tile just in here, then you can see, once again, I'll just hide my visualization. You can see that our collision responded to that and wrapped around in a really nice dynamic way. Super handy. It couldn't be any easier than that, huh? Just very straightforward. Now what we need to do is make it so that our player can actually go bump and fall and land, because when we click play, he's just standing there doing not much, just floating in space. So I'm going to give this to you as a challenge, and that challenge is to make your player fall and land. That make this even clearer. I'm going to grab the player, hit W, and just pop the player up in the world so it's going to donk and then land on the platform. Make your player fall and land, so figure out what components we need to add to the player, so when we push play, he falls and lands on the ground. And now a little bit of bonus points here, figure out how we can ensure the player doesn't fall over, doesn't kind of slowly rotate and go bump and land on his face, which can happen if we do things a particular way. So there's your challenge. Pause the video, take that one on. Okay, so there was a little bit of a clue in the sort of collider I'm going to be using on my player because I was talking about having it fall over. So I'm going to work directly on the prefab, click my little arrow here. Now I'm in the prefab. I'm going to click on add component and we'll add a capsule collider. Make sure it's the 2D so you don't sit there for a while saying, why isn't this working? We'll do a little bit of editing on this. At the moment, it's a big round ball that's a little bit fatter than what Ginger is. I'm going to click on edit collider, grab the handles to the right, and to the left and up and down, just a little bit of finessing to cover most of the player. Right, happy with that, that's good. Unclick out of the edit collider. Next, what we need to do to have our player actually respond to gravity and physics is what? We need to add a rigid body. So rigid body 2D, and our rigid body 2D, let's open that up, have a look at it. Dynamic, yes, because we want him to be moving around, unlike our world, which is going to be static. And I'm going to find the constraints box in here because we've got a capsule collider and we've got this rounded bottom. There's the possibility that our player will slowly kind of go brr, 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 and roll onto his face because he's standing on this rounded edge. The rounded edge I like better than having the square collider or the rectangular collider because it doesn't have these sharp edges that can catch on things. It's got this nice rounded edge, smooth edge, makes it easy to bounce around and do stuff. But I need to freeze the rotation on the Z axis so we can't accidentally roll forward onto our face. So I think that's all I need to do. Let's move back out of our player prefab, click on play, and our player should drop to the ground. They blump and land nicely and not roll over, fall flat on his face. So there we go, next stage in getting our player ready for running around and jumping and platforming. Good stuff, I'll see you in the next lecture. In this lecture, we're going to set up our new input system so that when we push left or right or up or down, we're printing to the screen the -1 to 1 on the X and Y axis for our controller input. I'm going to jump over to Package Manager, so making sure I'm on Unity Registry, I'm going to search for Input System. If you don't have it installed already, then click Install. That'll give you this fancy warning. Click Yes, we're okay with all that stuff, and that will cause Unity to reboot, restart itself, and go through a setup process. Now with the input system set up, first step, click on Player, Add Component, Input, Player Inputs, what we're looking for here. Why have I got all this noise going on? Feels like there's a lot of words on my screen at the moment. Let me just shuffle things around a little bit. Okay, so the first thing we need to do here is create actions. Click on that. That will ask, where would you like to save it? I don't have a folder for this at the moment, so new folder. I'm going to put this into Input System. I think it's a nifty place for that. Double click on the folder, save. We'll get an error. That's okay. That'll go away shortly. Let's have a look and see if we can find where that ended up. So we have our input system. There we go. We've got our TileVania. I didn't do a very good job of renaming it, did I? I just clicked enter, but TileVania is okay. You could probably rename it Input Actions, but I'm just going to have the one here, so it doesn't matter so much. Back over to the player. Now we need to make sure we drag that over into the action so it knows what we are actually doing. I'm going to double click on that to open it up to see what's going on here. The action's already set up, move, look, and fire. We're going to be using move a bunch in the next couple of videos, and then after that we'll also be wanting to be able to use jump. We have a fire in here. I'm not going to use fire for jumping because it's, well, you know, fire is fire and jump is jump. We might wish to do fire at some point later on. So let's set ourselves up a jump action. I'm going to click on the plus button here. I'm going to add in the word jump, and you can see it's of action type button. That's what we want. We don't want to have a value for our move. Let's see here. We have a value, which is a vector 2 on the lefty righty, uppy downy, which is X and Y. But here, jump, that's cool. It's a button. Let's change the binding to, let's see here. On the keyboard and mouse scheme, I'm going to click on the pull down selector thing here. So one thing that's really cool, you can click on the listen button. It's not literally listening for what you're saying. Spacebar. It's not quite like that. It's listening to the keyboard input. So if I tap on the keyboard, it will show me that I just push space and I have space as the option. So I'll add that there. It's also, let's see, if we go next to jump and add another one, add a binding by clicking the plus button, click on the binding, we will make this the gamepad setup. We'll click on our little selecty thingy here, listen, and I don't have my controller turned on, but if I did have it turned on, then it would also listen for that. But I'm going to find gamepad and then just find button south. That's the button down the bottom of the 4 buttons on our gamepad. So now we've set up jump, which we'll use later on in this section when we're setting up jump for the character. Okay, we can close that out. We don't need it anymore. Back over to player. I need to also open input settings and create a settings asset. And that should be good to go with all the settings as they are in there. Now we have this input system settings asset that can sit down there and do what it's going to do. And you'll see we're using send messages. And here are all the messages that are available to us. Very similar to the way we've used on trigger enter, or we've used on collision. These are the same sorts of things. You can see on move is in there already, and because we've created jump, it's sitting here as an on jump. Now, just to illustrate this super clearly, if I was to double click on my, actually while I'm here, I'm just going to grab my input system and pop it into the input system folder. So there we go. That was the input system .asset. No, yes, .asset it is. Great. I'm going to open up my input actions again, and input actions in here. If I was to go and create a new action and I called this donkey blah blah. Why donkey? Well, you tend not to have donkey anywhere in your programming, in your coding. So if you search for donkey, you'll be able to find this pretty easily. It's a Ben Tristram thing. Thank you, Ben, for giving me that habit of using donkey as your word to search for. Now, when I click back on here in behavior, you can see that we have on donkey blah blah. That is now an option that if we had that bound to something in here, so currently it's not bound to anything, but if we were to bind that to something, then when that particular binding is executed, when a button is pushed or a keyboard key is pressed, then it will send the message that we want it to send over in here. It'll send the on donkey blah blah message, and then we can set up whatever code we want within that. So I just wanted to illustrate, for me, when I was first playing around with this, I was thinking, how do I access jump if there's no on jump? But it gets created for you when you create that new action, which is pretty nifty. Let me just very quickly get rid of donkey, delete, right click delete, just so it's not lingering around there. Okay, now the other step is to create our script. So I'm going to click on assets, give ourselves a little bit more space here. It's getting running out of space, isn't it? These animated windows. We need a scripts folder, so right click, create a C# script. Oh, I did that in the wrong order. Okay, well, fine, my brain's not quite working. We'll make this the player movement script. Okay, and now we'll create the folder, create folder. I was too hasty with my clicking, wasn't I? And I'll call this scripts, and drag my player movement into scripts. So a little bit of back to front with my order there. We'll find the player, and I'm going to drag over the player movement script onto the player. While I'm here, I've been working in the instance, so I need to make sure I jump up to the prefab, under overrides, apply all, and then the player input and the player movement script will be applied to the prefab. Now let's open up our player movement script. We'll just do one or two very quick things here to get ourselves set up and ready, and then in the next lecture, we'll actually be making him move. But for now, let's just remove our comments. And because we're using the new input system, we need to first of all access the namespace using Unity Engine .input system, semicolon. Now, the core thing we're trying to do here is within update, we want to say move the character, make the character run based upon what input the player is pressing. And how do we know what the player is pressing? Well, as I pointed out before, we've got a message over in here, a message which is, hopefully you can see that okay, on move. On move is going to be called when the player changes what they're doing on the keyboard or keypad based upon our binding. So if you're pushing left or pushing right, or if you let go of pushing left or let go of pushing right. But because it's a message, it's saying the player pushed down left, there's a change. The player let go of the left arrow, that's a change. The player pushed right on the gamepad. So we need to grab that input at the moment that it happens and then store it into a variable that we can then use within update to say on every single frame, whatever is currently the setting or currently the input value, then continue to use that to update our player's action. Okay, so that's a bit of a wordy explanation. Hopefully it helps a little bit. I'm going to start with a vector 2 because we need the X and the Y. We're looking at the character movement, and I'm going to call this move input. And this corresponds to whether you're pushing right or left, up or down. We want to store it into move input. How do we find what move input is? Well, we can put some information in our onMove method that's a message and is going to be getting called when the player makes a change to the key binding that we've got. And we need to get some information when that is called. And the information we need is an input value. We need a particular value, and we'll just name this value. So the type is input value. We're giving it the name of value. And then we want to store our value that we're receiving from the input and store it in our vector 2 that we can use throughout our class in any of our different methods within update, etc. So the way we're going to do that is very simply move input equals value.get. And then what do we need to get here? We need to get the vector 2 parentheses semicolon. So there'll be a particular value and we want to assign that value to our move input variable. Now, as the last step in here, let's check that this is working. I'm going to just do a debug.log. What do you think we're going to log out? We're going to log out move input and save that up back over into Unity. Let's see how that worked. We'll see if it did or didn't work. Clear some errors here. There's always going to be something that Rick has done wrong. Method must have a return type. Oh, Rick. Oh, Rick, what have you done here? We need to have void in front. My apologies if you were yelling at the screen while I was doing that. A little bit rusty today, not paying attention. That should clear things up. Okay, we'll click on play, back into our game, and let's see if that's going to work. Left arrow, yeah, right arrow, cool. So it's showing that there's some change when we lift up or push down, lift up, push down, as we've done in previous lectures. We now have our input for up, down, and left, right. And in the next lecture, we can get our character running left and right. So good stuff. I'll see you in the next lecture. In this lecture, we're going to be making our player drop from the sky and run left and run right when we push on the keys on the keyboard. So let's get started. First question I have for you here is, what do we need to access on our player to make the player move around? What's the core movement thing that physics applies to or allows us to push the player around? It is the rigid body. So well done if you guessed that or yelled it at your computer out loud. So we need to access the rigid body. Let's start in our script by caching a reference to rigid body. So if you know how to do that, pause the video and do that now. And if you're thinking, what's Rick talking about? Let's do that together. So I need to create a variable, which would be a type rigid body 2D. Don't forget the 2D. I often forget that. Also, there's not a capitalization on the B, which I mess up as well at times. And we'll name this rigid body. Actually, I'll name this my rigid body so that it doesn't complain. Sometimes it doesn't like when you just do rigid body because it thinks you're referring to something else. So my rigid body and semicolon. Now within start, what do we need to do? We need to my rigid body equals get component. What sort of component is it? It's a rigid body 2D parentheses, semicolon. Okay, now we've got a rigid body. What do we need to do? Well, we need to create a run method. We need to say, move this way, move that way, run, based upon what the player input is. So first of all, in update, I'm going to call the method run. I haven't created this yet, but I'm going to say run. What does run mean? Well, let's jump down right below on move. We will create ourselves a new method, void run, parentheses, curly braces. So let's start with a really simple implementation, and then we'll make it a little bit cleverer. So within here, what we're trying to do is say my rigid body dot velocity. That's how we're going to be moving around our character. Equals what? Well, we can just say for now equals our move input. That's our vector 2. Move input. Semicolon. Save that up. And then jump back into Unity. Click on play. What happens in here? Well, we can go left, right, up, and down. Excellent. But it's kind of weird. The player's floating, which we don't want, and the player's moving kind of slow, which we don't want, and the player's actually being able to fly up and down. We only want the player to be able to move up and down when they're on a ladder. Let's tidy up our run method in here to be a little bit more sophisticated. So rather than just straight up move input, let's create ourselves a new variable, which will be of type vector2, and we'll call this player velocity. And that equals, and we know we can't just say that equals 1 and 3, because Unity will say, I don't know what you're talking about here, 1 and 3, what does that mean? So we need to say, well, I'm going to give you two values, and it will be in a vector 2. So new vector 2, we cast it to a vector 2, and then player velocity knows what it is that it's supposed to be receiving, what these numbers are that it's getting and putting into its vector 2 values. So what I'm going to do on the x-axis is move input. That's currently a vector 2, remember. I only want this to be on the x, so it's move input dot x to say, just give me the x value. And then comma, I mean, we could put move input dot y, we would get exactly the same behavior as we just had, so we don't want that. We want something different in here. We don't want the player to be able to push up and down unless they're on a ladder, and that will be in a different method, which we'll call climb ladder. We don't want that in run. So for now, I'm just going to put 0 and see what happens. Oh, and then the last step here is we need to make sure, instead of move input, we need to have player velocity as the values that our rigid body dot velocity is receiving. So player velocity. Save that up. Back over into Unity. Click play. Now, we can't move up and down. That's great. Perfect. But I can move left and I can move right. Now, we've got some weird behavior. The players are slowly floating down because we're saying 0. Don't give it any velocity. It's trying to resist gravity, which is not what we want. So let's go back to our code. I've got a challenge for you in here. And one is a simple challenge and one is a tricky challenge if you're ready for it. So the simple challenge, here it is. Add something to our script to give us control over how fast the player runs, because you can see it's not a very compelling platformer if you're only moving that quickly. So that's the simple one. And then the tricky one is try to figure out how to make the character behave normally on the y-axis. In other words, to respond to gravity, to not be able to fly up and down the air. We've already removed that. And to not get stuck. So not just to be sort of stuck there floating in the middle of nowhere. So see if you can have it. See if you can figure out to say, just behave normally. It's a tricky one, this one. So if you don't get it, no worries. But give it a shot. Have a think about it. See if you can wrestle with it and find the solution. So pause the video. Take that on. See you back here when you are done. First step, I'm going to add a new serialized field right up the very top. Serialize field, and this will be of type float, and I'll call this run speed. And I'll initialize that at, say, 10F, because it's a float. And that's going to be our variable that we will then jump back down here and run and say move input.x multiplied by run speed, so that we can speed up how fast we're moving. If we're receiving a -1 to +1, we can then multiply it by 10, so it'll be from -10 to +10 that we're adding to the player velocity, or pushing the player each frame. Now, what are we going to do about this pesky y value in our vector 2? What I'm going to do here is access the myRigidBody.velocity.y and say that's it. And what my logic here is saying that whatever your current velocity is on y, just keep that. Just do the same, because we're adding a new velocity each frame. We only need to be adding the x. We don't want to be touching the y. So instead of saying it's 0, we say just keep it as it currently is. So let's see. Before I celebrate too much, I'll save that and see if that worked. Click on play. Boop, drops to the ground, and left, right, we're running really fast. Probably a little bit too fast, but we can tune that later on. We can't move up, we can't move down, but the player is responding, boop, to gravity. There we go, falling off the screen. So there we go, we've implemented left and right movement for our player using this code, using our run method, so that we can move left and right with our player. I'll see you in the next lecture. In this lecture, we're going to flip our character. So running right makes our character point right, and running left makes our character point left. Just very quickly, I'm going to give myself a little bit more platform here so I can make my character run around without having him fall, and yeah, there we go. Okay, just a little bit more space to run to do what we're doing in this lecture. Now, I'm going to take you through a little bit of the logic, our flippin' logic for this lecture. Ha, dad joke. And we have our character facing right, and we're flipping our character, and our character is facing left. So if the player is pushing right, the velocity will be positive, yeah? Because we know from our control input, it's going from -1 to +1, and then we're applying our run speed multiplier to that. So if it's left, it's negative. If it's right, it's positive. If we're moving right, we want to face right. If we're moving left, we want to face to the left. So we can change the facing direction to the right or the left by changing the local scale using positive or negative values. So let me just show you that bit of our logic very quickly in here. Click on the player. We've done this before into the transform. If we look at the scale on the x-axis, +1 and -1, it will change our character. I'll zoom in a little bit here so you can see him doing his little pirouette. We have -1, -1, and +1. So that's basically what we're going to be doing in code, depending upon whether you're running to the right or running to the left. And then the last bit of our logic is to only change the facing direction if you're actually moving, so that the weird things don't happen when our velocity is 0. I might leave them in for our first point, and then we'll see what weird things happen, and then we'll put in a little bit of an if statement to say only flip if you are actually moving at the time. And the other bit of setup I'm going to take you through here, we're going to be using some different mathf methods. We're going to be using mathf.abs, which is absolute. It's not like rock hard abs of steel six-pack. It's abs as in absolute. And that is going to allow us to say, what's the absolute value of our number? If you're not familiar with absolute value, it means no matter what sign is on there, so positive or negative, we make it the positive value. So if minus 10.5, you can see in the example here, becomes 10.5. So it's a way of us just cleaning away the sign, so we just get the absolute value irrespective of the signs. That's mathf.abs. And then we also have mathf.sign. What does that do? Well, that allows us to return a value of 1 when f is positive or 0, and -1 when f is negative. So no matter what our value is, if we're pushing to the right, or we've got a thumbstick on a gamepad and we're pushing halfway to the right and it's plus 0.5 or it's plus 0.7 or if it's minus 0.3 or minus 0.8, whether it's positive or negative, we're going to return a value of 1 or -1, just so we can get the sign. And what do you think we're going to do with that 1 and -1? We're going to apply it to our player on the local scale. And the last mathf type thing we're going to use is epsilon, which is the smallest, a tiny floating point value, the smallest value. We try to use mathf.epsilon instead of saying 0. Sometimes we get some weird results if we say equal to 0, because technically it's 0.000001, so then we get some confusion around that. So it's good practice to say greater or equal to mathf.epsilon rather than to 0. So they're the three things we're going to be using. Now let's get into our code and use some of these things. First of all, we need to create ourselves a new method, and I'm going to start by calling the method, and I'll name this flip sprite. We don't have that yet, parentheses, semicolon, so we're going to go and create that. I'll create that underneath run void flip sprite, parentheses, curly braces. What are we going to do in here? The first part of this is we're going to access the transform.local scale of our object equals vector2, and we need to put the new keyword in front of that. Now in here I will start off with mathf.sign, because I want to get the sign of a particular thing. I want to know, are you a positive or are you a negative? And what do you think? Here's a little micro challenge for you. What do we need to get the sign of? Just take a moment to think about that and add that in if you think you've got the answer. Well, we've got a little bit of a hint up here. We've got myrigidbody.velocity.y. That's on the up and down. So let's use myrigidbody.velocity.x. So we know here's a velocity on the x-axis. Is it positive or negative? Because we need that sign. And then we don't want to change anything on the y-axis. Leave it as it is. So we're just going to put 1 in there for our vector2 that we're returning and that we're putting into our scale. Just leave that as 1. We don't need to go and change that. 1 is fine. Oh, let's save and see if it's working at this stage. There's more code for us to do, but it might maybe be working thus far. Click on play. Running right, running left. Oh, look at that. He flips. Running right, running left. Now, as I indicated, when he turns left and then I let go, he flips back to the right again. That's because 0, when you've got no velocity at all, is being treated as a positive. So that's the next bit of our logic. We're going to jump back into flip sprite and create ourselves a bool that says you're either moving or you are not. So bool player, what should we call this? Player has horizontal speed. I know it's a bit of a mouthful, but when we look back at this in 6 months' time, we'll be like, oh, I know what that means. Makes sense. Now, how do we find this? Well, we need to say, is your movement greater than nothing? But if we say movement greater than 0, that kind of thing, if we're currently moving to the left, our movement is going to be negative, and that's going to give us a bit of a mistake because a negative movement is still movement. So we want to use our absolute value in here. So we want to use our mathf.absolute, our rock hard absolute in there, and we are going to pass into this myrigidbody.what. What do we pass in here? Well, the same thing as just below velocity.x. We need to know what's the absolute value of your movement, and then we're going to say is greater than, and I gave you a hint, it's greater than what? Greater than mathf.epsilon, which is another way of saying pretty much 0, but a little bit technically cleaner. So we'll save that. We now know that. And within our actual flippy in here, we're going to say if player has horizontal speed, so in other words, if that is true, then we want to flip. Okay, we'll save all that up. Hopefully this explanation has clicked for you. I know it's a little bit tricky using math words and concepts in there. Anytime we play around with math, I know a lot of people kind of glaze over and say, oh, what are we doing? But I think we've got it right, left, and he's staying facing left because when we're stopped, we don't need to go and flip it again. Excellent. So there we go. We've now flipped our character sprite using a little bit of mathematics and a couple of extra methods in Unity. So great work. I'll see you in the next lecture. In this lecture, we're setting up so that when we run, we change to our running animation state, and then when we stop and idle, we're back into our idling animation state. Just a reminder in case you've forgotten, the animator window is where we can see the animator information, and if we click on play, you can see that the character is probably just going to be idling, I think. Idle, idle, idle. Yep, there you see the idle is going backwards and forward as the animation loops through, and that character is just idling on the spot. We set up before an is running bool, that if it's true, then see our character's running, and then if is running is false, then goes back to idling. So that's the essence of what we're trying to do in our code. We want to say if there's a particular condition met, then turn this bool to be true. What is that condition? Well, if we're running, of course, and that's going to come from whether we're pushing the controller or the keyboard right and left. So over in our code, the very first thing we need to do is set up a reference for our animator, or cache a reference to the animator. So a little micro challenge for you here. Pause the video and cache a reference to the animator. Underneath the my rigid body, I'm going to create a variable which is of type animator, and I'll call this my animator, using the my convention here. My animator, my rigid body, etc. Now within start, I'm going to copy the previous line. I don't know if that's going to save me a lot, but we'll see. Instead of my rigid body, it's going to be my animator. If I can spell animator, get component is going to be animator. So there we go, we've cached a reference to the animator that we can use in any place throughout this particular class. Now, where's the logical spot for us to have the animation play for running? Well, it's in the run method. So give ourselves a little bit of space in here. We'll start by doing this in a simple way, and then we'll improve it after that. So the simple way, my animator dot set bool. That's how we can change the bool from true to false. And in parentheses, the first part of this is the name of the bool. So I'm going to jump back over into my animator, just click on is running a couple of times, copy that so I get the exact spelling. There's string references. We don't really like string references, but sometimes we use them just because we gotta. And then comma, and we'll say true. That will set our animation to be is running. Let's see if that works. First of all, click on play. And instead of idling, you can see our character is running, as evidenced by our animation looping through the running state. Excellent, so that's the first part of what we wanted to do, but we need to set something up so that we're only running if we're actually moving. And the challenge is to finish the run state. So make the is running bool true if we're running and false if we're not. And if that's enough for you to go on, if you're ready to dive into that challenge, take that on now. If you want a hint, I'll give you a hint, and that hint is going to be to use the code we created for flipping our sprite. So somewhere within flipping our sprite, we were saying, if the player is actually moving, then do this thing. So you can grab a line from that previous code we created to see if our character is moving. So pause the video, take on that challenge, see you back here when you're done. What is this mysterious line I speak of? So bool, player has horizontal speed if our velocity is greater than 0, or mathf.epsilon. So I'm going to copy that, pop that just above our myAnimator.setBool. So we now have a bool within the run method that knows if we're moving, and instead of myAnimator.setBool is running true, instead of true in here, we want this to be true if you're running, false if not. So we can just use the same bool. Player has horizontal speed, because this will resolve as true if you're moving and false if you're not moving. So save on that, back into Unity, click on play. So you can see on the screen, the character's running, boop, 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 little skipping along when we're running, and also you can see the states are flipping backwards and forwards when we're running and not running, and our character sprite is still flipping in the right kind of way, so everything's good. This is just the first state. Running will have climbing and probably a die state and a couple of other things later on, but I just wanted to show you the fundamental mechanism of changing our animation state in our code. Good stuff. I'll see you in the next lecture. In this lecture, we need our character to jump, so we're going to implement the code for jumping and do a bit of tuning. Now, we could add a jumping animation, but I'm okay just using the running and idling, depending upon what the player's doing. I think that'll look fine. If you jump and it's still using the running animation, that is okay. Let's have a little bit of a reminder in our input actions information. We created a jump method, or jump action, sorry. And this jump action automatically creates the on-jump message. The on-jump message, what's inside that? Well, nothing yet, because we haven't created it, but we will create things that the game will do when on-jump is called. And when is it called? Well, it's called when either of these two bindings is enacted. So when space is clicked, or when button south is clicked. Enacted, that's not a word I use every day. Anyway, we've learned something. And so here is jump, and as I showed you before, if you click on player and look for the player input, you can see that one of the messages down in here is going to be on jump, just there. So over into our script, our player movement script, let's see, underneath on move, I will create void on jump. And once again, we need a particular value to be passed into us. We need to know whether the button's pushed or not. So we will create input value. Once again, we'll just call this value. And then in our curly braces, And on jump is a little bit different to our on move and our run. So on move, we wanted to know what's the vector 2, and because it doesn't change every frame, it might stay on, say, +1 while the player is holding down a key. We needed a way of storing the +1 up here in our move input, and then in update saying, hey, continue to run if the circumstances are appropriate. In other words, it's greater or less than 0. But with jump, it's a button, so we don't need to be putting this into update. It literally is when the button is pressed, do a thing. So I'm going to create a bit of an if statement. If the value dot is pressed, that's our way of doing it. Up here it was value dot get vector2, but this is value dot is pressed. If it's pressed, then do some stuff. Do stuff. I'm giggling because I was about to write do stuff, which is incredibly sophisticated programming. Starting point, we know we're working with the rigid body and also with velocity. And this is where we want to add a force to it. We want to throw some velocity onto this. So I'm going to plus equals. So take whatever your velocity is right now for up and down, and then add something to it. And what will we add to it? Well, we'll create a new vector2. Once again, we need an X and a Y. On the X, we don't want to be adding anything. So I think we can just say 0 on there. Don't add a new thing. With run, we were assigning, so the velocity is now this particular velocity, but within the jump, we're adding. So we're saying take what you've got and add some more to it. We don't want to add any more to the X, so we'll leave that at 0. And then to the Y, we want to add a certain amount. So I don't know what that certain amount is yet. So we'll call it jump speed as a new variable, semicolon, and we'll jump up to, pardon the pun, jump up to the top, serialize field, and we'll make this a float and jump speed. Initialize this at 5, maybe. 5F semicolon. Back down here, so jump speed should be cool now. Let's save that and see if it actually works. Click on play. Jump is assigned to spacebar. Boo, there we go. We are jumping. Whoa! And that is some serious distance we get with our jump just there, because we're floating in the air for quite some time. So that's a win. Let's have a look at some of the issues in here. If I was to push the spacebar twice, once, twice, 3, 4, 5. Okay, so that's an issue we'll need to address in upcoming lectures. What else can we do? Well, we're going a really long way. That might be what you want, but it's not really what I want. And if we fall down here, could we actually get out of there? No, we couldn't. So there's some things we need to tune for our character. Let me show you a couple of things, and then you can go ahead and tune this yourself. The first thing, if we go up to Edit Project Settings and look for Physics 2D, within here we've got a gravity setting, so we can make the gravity heavier for the player, or we can make it lighter. That's one place we could change it, and this will change everything in our game world. It'll change things we shoot, it'll change enemies if we change our gravity here. That's a holistic gravity. Or we could click on our player and then find within our rigid body, you can see the gravity scale for the player just here. And if we wanted to make the world heavier or lighter, we could change it in here. And so if you were changing the gravity for everything in your world, then you'd certainly want to go into the project settings and the physics 2D in there, so it changes for everything. But I'm pretty much only going to care about gravity for my player, so I'm just going to do it directly in here. We'll make the gravity twice as strong, and then see how that goes. So gravity scale of 2. Okay, that's pretty good, but now he's not jumping anywhere near high enough, and that's going to be changed within the player movement script, and you can see our jump speed is 5 in here. So it's time for a challenge, I think. Tune your jump. Using the gravity and jump speed, tune your jump so it feels good. Decide how many tiles you want your player to be able to jump up. So if I run my player at the moment down to this little bit where I've got the jump, ignore the water for now, it'll do some watery stuff later on. But down here, I can only jump maybe 1 tile. I can't even get out of this. This is 2 tiles in here, 1, 2. I think I want my character to be able to jump a little bit over 3 tiles. So that's the tuning I'm going to be aiming for. And then decide how far you're okay with your player floating horizontally when jumping. So all these things are combined to say, well, what should I tune it to? Tune it based upon the performance you want your player to have. So there's your challenge. Take that on. See you back here when you're done. Okay, first thing, I need my character to jump higher. So jump speed, we'll put this to 15. Click on play, see what happens. Jump down here. Well, that's now far too fast. So they make the gravity heavier or the jump speed less. I think I'm going to try the gravity heavier. While I'm still in play mode, I'll do this so I can change these things on the fly. That's pretty good. It's floaty. He gets quite a long distance though, doesn't he? So jump speed we'll put to 20. Gravity will plop up to 4. See how that impacts. Whoa, he's flying way too far. Gravity we'll put to 10 just to be crazy. Okay, and there's a good issue that we've spotted just there, that he fell right through the world. So I'll get back to that in a moment. Just mental note, I think maybe 8. So 8 on the gravity scale, and I click out of play mode. It's going to go back to what it was. 8 and 20 I think I had here, jump speed. We'll see how that goes. And I'll play around with that a little bit more, but we just want near enough is good enough for the moment. The other thing was with the player missing the collision. That's because we currently have our collision detection on discrete. We want to change that to continuous. Continuous is better for things that are moving a lot and moving quickly. It's a little bit more expensive computationally, so we only want to do that really for the player character and anything really important. Pop that onto continuous. We'll see if we still have that problem. Okay, this was the spot. Looks pretty good. I like the speed now. The player can get a reasonable distance. It feels pretty good, actually. The only test I've got now is, can he reach the third level? So I just need to make the jump speed a little bit more, then I think I'm done. So 25, but I'm going to put it somewhere around 25. My gravity, I think, was somewhere around 4, wasn't it? So there we go. That's feeling pretty good. It like bings like a little jumping jack. I kind of like the feeling, but you can have yours tuned however you like that works for you. Mine's at gravity scale 8 and jump speed 25. So there we go. We've implemented basic jumping into our game. There's a few more things that we need to resolve with jumping, a couple of bugs, but we've got the basics for it. Okay, see you in the next lecture. Rightio, in this lecture I'm going to be showing you a technique to stop our player being able to do this mid-air jump and fly off onto the screen. And the way we'll be doing that is using layers. We've already had a look at layers a couple of times. We've looked at sorting layers. So let me click on the platform tile map here. You can see under layer, we've currently got default. That means the collision layer. I like to think of it as collision layer. If we go and click on add layer, you can see that we've got sorting layers, which we've played around with. That's the visibility, what will be displayed first and displayed second so that our platforms are on top of the background. We've also got these other layers in here. The way we mostly use these is when we're looking at collision, but there's a few other usages. For example, layers are useful if you have the same functionality across multiple game objects. What do I mean by that? Well, if you want a whole bunch of things ignored by the camera, or a whole bunch of things to be not clickable, or a whole bunch of things, like in our case, to be doing a collision check. And if we jump over to the main camera over here, you can see that the main camera uses this sort of collision for the culling mask. What's a culling mask? Well, that's a way of saying what can you see or not see. The mask is where we group a bunch of things together. So if you see my little main camera view down here, our preview, you can see that we can see all our level and stuff. If I was to go into the culling mask and select on nothing, we'd see nothing, just the solid background. That is because everything has been culled by the camera. What we'll do, we'll click back on everything here. And so we could set up a new layer that said only show, through the camera, only shows certain things, only show, say, the ground or the green things or the enemies or whatever. You can turn things on and off in the camera using this culling mask. For us, we want a ground layer. So I'm going to click back on my platforms tile map, just so I'm in the right ballpark. Click on layer, add a layer, and then use a layer number 6, or wherever, it doesn't matter what number you attach this to. I'll create a ground with an uppercase G to keep that convention. So now that we've created ground, click back on the platforms tile map again and change the layer to be the ground layer. One thing we do need to have a quick look at here, if you go to edit project settings and find physics 2D, scroll down, you can see there's a little matrix down here which says which things will collide with which other things. And you can see that we've got ground, and that is lining up with default, our FX, etc. We've got a few defaulty kind of things in here. So if you were to uncheck something in here, that would say this thing can't collide with that thing. So if we had another layer in here, which was, for example, enemies, and if we unchecked the relationship between enemies and ground, then there's a chance the enemies would just drop through the ground and not actually collide. So sometimes if you get a little bit of issue and you're like, why are things not bumping into each other, you might just want to come in and check that matrix, that collision matrix, just to make sure things are checked appropriately. For us, for now, we're just going to have everything colliding because that's the way it's going to work in our game. But you could absolutely have something in your game where you say, well, I want the player to be able to run straight through something and not bump into them, whereas I want the enemies to bump into those things. So you can play around with your collision matrix that way using the layers. What are we going to do? Well, we're going to stop the player jumping anytime they please. That we're going to say only jump when you're touching the ground layer using Collider2D dot is touching layers. Let's have a quick look at a couple of Unity docs. Collider2D dot is touching layers. This is going to return a bool, which will be true or false depending upon whether or not this collider, so wherever we place this, in our case it's going to be on the player, whether the player's collider is touching any collider on the specified layer mask or not. So in other words, is it touching any of the colliders, all these many colliders we might happen to have placed on the ground layer? And the other doc is layermask.getMask, and you can see here it returns the layer mask created from the layer names. So we need to know that we're dealing with the ground layer, and the ground layer is going to generate a mask, and we need to have a way of getting that mask. And so this all leads to a challenge where I'd like you to finish the logic to stop our player multi-jumping. I've given you a lot of clues, but not the exact recipe for doing this. You will need to use the collider2d.isTouchingLayers, and you'll also need to use the layermask.getMask. You'll need to make sure that you're accessing the player's collider, and also you'll need an if statement in there somewhere. So give that a go, pause the video, take on that challenge, see you back here when you're done. First thing I'll do is to set up a reference to our collider. Now, our particular collider on the player is a capsule collider. So I'll specifically say, let's find the capsule collider. Capsule collider 2D is going to be the type, and then we'll call this my capsule collider, semicolon. And then in start, we need to get our component. So my capsule collider equals get component. What's the type? It's going to be the capsule collider 2D parentheses semicolon. So we're looking at on jump, and in here we've got some functionality. If you press the button, then you can jump. We could add in a, and add some more criteria, or we could wrap all of this in a if statement that says, if you are not touching, then do these things. Or we can do it another way, which says, if you're not touching the ground, then don't progress to any of this. Just return. Don't do any of this stuff. So the way we're going to write that is say, if I'm not doing a particular thing, what am I not doing? Well, if my capsule collider dot is touching layers, and then which layers are we interested in? Well, this is where we need to use our layer mask, get layer mask dot get mask, and then the particular layer we're interested in is ground within uppercase G. We remember that. If you're not touching, then we could write it like this. Just simply return. That means get out of this method and don't go any further. I'm just going to tidy this up so it's a little bit easier to read quickly, and I'll put all this on the one line. So we can add return up here. Return. There we go. All on the one line. Let's save. Head back to Unity. Make sure that we have all the things hooked up. So the platform, yep, that does say ground. That's cool. The player does have their capsule collider. We'll click on play. We've got an error. That's going to be Rick doing something dumb. And you know what? After pausing the video and messing around here for a while, I've discovered that I spelt something incorrectly. I need to spell is touching layers with an uppercase I, then saving, jump back over into Unity. My error should go away with a different sort of warning that says, Rick, make sure you check your spelling. Dunderhead. Click on play. Now let's see if our functionality is as we want it. I can jump, but I can't jump over and over. Excellent. Despite tapping the spacebar a whole bunch. So there we go. We've stopped our player doing the extra jumps. You can only now jump when you are touching the ground. Okay, I'll see you in the next lecture. In this lecture, we're implementing some ladders so that we can climb up the ladder and climb down the ladder, and I'm going to give this to you as a big old challenge. So let's get started. Just a reminder, you've got a piece of the ladder that you downloaded, hopefully when you downloaded all of this sprite set, so you've got the ladder piece in there. What we're going to do straight away is take on a mega challenge. So the mega challenge is going to be to implement ladder climbing. We've done all the different elements of this, so this will be a good opportunity to bring it all together. Remember, you need to set up your climbing tile map. Well, I'm going to call it climbing. You can call it whatever you want. You could call it ladder if you wanted, but just in case we have things other than ladders, say ropes in the future, I'm going to call it climbing, and also the climbing layer, so we can check to see if we are currently touching something that should allow us to climb. To create the climb ladder method, check to see that we're touching the ladder, and to apply climb velocity to the y-axis if we are pushing up or down. And then in the next lecture, we'll be setting the animation, and there's also an issue where the character slowly slides down the ladder, so don't worry about those just yet. We'll do that in the next lecture, but get the base functionality of climbing the ladder set up. Take on that challenge. See you back here when you're done. First step in here, let's set up some of our functionality. I will go over to my tile map grid. Right click, 2D object, we will find tile map, and I'll create another rectangular tile map. I'll call this the climbing tile map. While we're here, I'm going to go over to my layers. We do have ground. I will add a layer In addition to ground, we'll call this climbing. Great, and then back over into the climbing tile map, and we'll change this to be climbing right there. We should also do our sort order at the same time, shouldn't we? So I didn't mention that in the list of thingies to do, but it just popped into my brain just then that we'll need to have plus layer 5 we'll call climbing. I imagine the climbing layer we'd want to have on top of the platforms underneath the player. So the player should definitely be on top of the ladders. The ladders could be on top of the platforms, I think, but that's up to you, and that should be okay. Now within our tile palette, I'm going to grab my ladder and just pop it up in the top there. It'll ask me where I wish to save that. We have our assets, sprites, and you know, I put the rule tile in there because we needed close access to it, but we don't need that for our ladder. So I'm going to pop my ladder into the tiles. We'll call this SPA ladder, that's fine, save that up. And now in our palette we have a ladder. I'm going to click on that and pop one into the scene. We can't see it, that means we've done something incorrect in here. First of all, am I on the right tile map? Yes, I am. Am I clicked on the thing? Yes, I am. Let's have a look what else is going on here. Click on the climbing tile map. It could be that we haven't actually said what the sorting layer is. So under additional settings, sorting layer, we need to say that I am climbing. Blump, hey presto, there we go. Okay, I also didn't tell you to do this, but hopefully you've figured it out that you need to play around a little bit with the collision on the ladder. So let's have a look at what we've got on our platforms. We have the tile map renderer tile map, and there is a composite collider 2D. That looks like what we need. So back over into our climbing, we'll add a composite collider 2D. And of course, we need to add a tile map collider 2D to that. And you can see we have a collider on there. Now, that doesn't look like a very good collider, does it? So let's go and edit that. If I jump onto my sprite itself, so click on the sprite, and you can see we have the sprite editor in here. We can jump up to sprite editor and change the custom physics shape. And within custom physics shape, I'm going to click in the top left, drag all the way down to the bottom right, blump. Okay, now we've got a custom shape. I'll just bring these in a little bit because sometimes you don't want the player kind of hanging right on the edge of the ladder. You want to make sure they've got themselves a little bit in the middle of the ladder. Now if I click apply, X out of that, click on my climbing tile map, and it may not look right for you. It might still look the old way. I had to unclick and click back on the tile map collider for it to take on that physics shape that we put on it. I still don't like we've got the little green lines in there. I'll have a look at that. If we get stuck on those, then we'll play around with a few things here. It looks a little bit buggy to me, but we may have done something wrong. We'll come back to that if need be. What we need to do next is jump over into our scripts, jump on player movement. I'm going to find, I'll create a climb ladder. In update, climb ladder, parentheses, semicolon. I like to have the things in the order they appear. Run, then flip sprite, then climb ladder. We've got run, and then flip sprite, and then down the bottom here we'll do our climb ladder. So void, climb ladder, parentheses, curly braces. Let's do the movement stuff first. So we need to give ourselves something very similar to run. So what do we do in run? Well, we had a vector 2 that was all about the lefty-righty, and that's the x-axis, and then we applied that to velocity. So I'm going to copy all of this, copy, pop this down into climb ladder, pasty. It's good, I think, to, once you've understood the concept, it's okay to reuse your code, as long as you know what you're doing. You don't want to just copy and paste and have a big old guess at things. That's not so good. Instead of player velocity, let's rename this climb velocity. Actually, I'm going to highlight climb velocity, highlight copy, and then change that in the other spot. There we go. So basically we need to flip these around. Instead of saying keep your existing Y velocity, we're going to say keep your existing X velocity. So you know what I'll do? This is going to look a little bit messy, but I'm going to do it the messy way just so you can see what's going on here. Copy that, pop it up to this line above. New vector 2, it's one of these things. And in here I will delete the first bit of that. Delete. And I'm just basically using the line below. I'm doing it this way so you can see really clearly what I'm doing on my screen. My rigid body dot velocity dot x is the first part of our equation, comma, what do we need next? Well, we need this move input times by some sort of climb speed. So we will move input dot, this is y this time, multiplied by, we don't have it yet, but we will multiply it by climb speed. Okay, and then I'll delete that just so we've got rid of it. Climb speed we need to create, double click, copy all the way back up to the top. We'll find our serialized field, and this will be of type float. We'll call it climb speed, and we'll initialize it at 5, just because that seems to be a nice number to initialize all these things at. All the way back down again to climb ladder. We've got our velocity being climb velocity. Great. And then the other thing we need to do in here is make sure you're only able to climb if you're touching the ladder. So let us create our if statement. You know what? Once again, we'll go find what we did in, what was it? It was on jump. That was if your capsule collider is touching a particular thing. So I'll highlight that, copy it, pop down to climb ladder. If not, my capsule collider is touching layers, mask, get mask. What is the mask we're interested in here? It's going to be climbing with an uppercase C. How do I know it's climbing? Back over into Unity, click on our climbing tile map. You can see that we've got a sorting layer climbing. Scroll to the top, you can see we've got our layer climbing. If I was to click on that, go to the add layer, I could double click on here, copy that to get the exact naming, so I know I haven't messed that up. And then back over into our climb ladder method, and we're using climbing as the particular layer we're interested in. So this is all just exactly the same as the previous lecture where we're talking about the touching a particular layer for touching the ground so that we could jump. If you're not touching that, then return. Don't do anything further. If you are touching that, then we're going to do this particular thing. Let's save that up and see how we're going with our functionality thus far. Double check that we've got our climbing tile map set up correctly. It is climbing and it's called layer climbing. Click on the player. There's going to be some error somewhere in here, I'm sure. Run. Whoop. Nice. And we knock over our ladder. That is, my friends, not at all what I was expecting. The reason that's happened, if we click on the climbing tile map, the rigid body on our ladder, that was kind of funny. I totally wasn't expecting that. We don't want it to be dynamic, do we? We want it to be static, so we can't bump into it and knock it over. I can run up to it, but, you know, bump, I'm bumping into it at the moment, and that's not what we want. I can climb a little bit, sort of, when I've bumped into it, but we need to resolve this bumpiness. So if you've got this behavior as well, or if you've just been following with me, just have a think, pause the video, and see what we need to do to stop us bumping into this. And you know what? Anytime you bump into something that you want to run through, it's usually because we need to make it a trigger. A trigger is a type of collision where it doesn't stop the rigid bodies moving. It doesn't allow us to have that bump into effect. So we'll make our tile map collider an is trigger for our climbing tile map. And when I run over, I can move up and I can move down as well. Excellent. So that's exactly what I want. Can I jump off the ladder? No, I can't at the moment, because we have set up our jumping so that you can only jump when you're touching the ground layer. So that's something for us to consider. Do you want your player to jump off a ladder, or do you want to say, no, if you're on a ladder, you have to float off the ladder? But for now, we've got the functionality that I wanted, which is we can run up, we can run down only when we're touching a ladder, and we've got the drifty issue that I was talking about. We're slowly floating to the ground, and also our animation continues to be the idle animation. So those are things we will work on in the next lecture. Good stuff, and I'll see you in that next lecture. In this lecture, we're going to fix the issue where the player is slowly sliding down the ladder when we want the player to kind of stay stationary when they get onto the ladder. The way we're going to do that is messing around with gravity. So let me just show you something here. If I was to turn the gravity scale on the player to 0 and then run to the ladder up there, the player's not going to drop at all. There's no gravity whatsoever. Now, I've set it to 0, which means that also, if we run around in the world, I'm not going to be dropping. So I want in code to say the gravity scale is 0 when the player is standing on the ladder. Now, I know that's not how the world works. If you climb up a ladder to get to the roof of your house, the gravity doesn't go to 0, because if you fall off your ladder, bloomp, you're going to, fall off and hurt yourself. But in this case, we're using that mechanism as a way to say don't slide up and down your ladder. So this will be our challenge to stop the player sliding. Set the starting gravity on the player rigid body to the rigid body's current gravity. So you'll need a way of finding out when we start our game what is the current gravity for the rigid body, and then to set a variable which is to say this is the gravity when we first start our game. And then when the player is on the ladder, set the gravity to 0. And obviously when the player is not on the ladder, then set the gravity back to what the starting gravity is supposed to be. So there you go. There's a bit of a different sort of challenge. Pause the video, take that on, see you back here when you're done. We'll be here in our player movement script. Up at the very top, I'm going to create myself another cached variable, which will be of type float. And that float we'll call gravity scale at start. Nice big name, should make sense when we look back at this in the future. And within my start method, I need to define that as something. So gravity scale at start is going to be equal to my rigid body, because this is where we find our gravity. Just a reminder, if you're like, how do you even know to do that? So if we go back to rigid body is the thing that controls gravity for the player, for this particular game object, you can see the gravity scale is 8. So it's rigid body 2D dot something to do with gravity. So if we jump in here, my rigid body, which is the way that we've cached our reference to the rigid body 2D. So my rigid body dot gravity scale, semicolon. And that in our case equals 8. But if we go and change our gravity scale in here, then it will be updated nicely. If we're not currently touching the ladder, then we want the gravity to be the same as the starting gravity. So I'm going to expand this out now, my nice little neatly compartmentalized return. We'll put this on its own new line, new area. Return will stay at the bottom, because if you're not touching it, we still want to return and not allow the player to climb. But I'll add something in here which will be my rigid body dot gravity scale is going to equal gravity scale at start. So I just want to make sure we've got the right gravity. So if you're not touching the ladder, then use the gravity scale that we had at the start. However, if you are currently climbing, then we'll pop down here, my rigid body dot gravity scale equals what? Equals 0. Don't give the player any gravity. And it's a flow. We'll put F there just to be complete and thorough. We'll save that and see if we've got our desired effect. Gravity should be normal unless we're touching the ladder, in which case it should be 0. Click on play. Jumping works okay. Climb the ladder works okay. And we're stopped here. You can see if we look over in our rigid body on the player, it's 0 when I'm on the ladder. I jump off the ladder, it goes back up to 8. Perfect. So there we go. We've got the right behavior that we wanted when we're on our ladder. We can't, we're not slowly drifting down. We don't have our animation set up just yet, so I think it might be time to do that in the next lecture. Okay, see you in the next lecture. In this lecture, we're setting up our animation so that when the player runs up a ladder or down a ladder, we play the ladder animation. But if you're just chilling out and hanging on the ladder, we'll play the idle animation. And we'll also make sure the player can just drop off the ladder and be able to run around still. We've already set up our climbing animation state, and we have our is climbing condition in here. So I'm going to give this to you as another big, not many hints type of challenge to set up the climbing animation so that it plays when the player climbs the ladder. If the player is stationary on the ladder, the climbing animation should not play. So it shouldn't look like you're trying to climb if you're standing still. I think it's okay just to have the character idling that says, hey, you can jump off the ladder or walk off the ladder if you want. So good luck with that. That's all I'm going to give you for this challenge. Pause the video, take that on. See you back here when you're done. Now, over into our script in here, I'm going to look under climb ladder, and first thing I'm going to do is jump down underneath where we were previously playing around with the gravity scale. In here, I'm going to say we're currently climbing, so therefore we wish to change the animation, and that's through saying my animator dot set bool, because we're using a bool in here, you're climbing or you're not climbing, and it will be climbing. Make sure you get this exactly right. It's always worthwhile to jump back into here. Oh, and I might have messed that up actually. Copy is climbing. Back into our script. It's not climbing, it's is climbing. Climbing is the state, is climbing is the particular bool that we're setting. So is climbing, and then comma, we'll make this true just to do this as a quick way, and then we're going to improve this as time goes on. So if you're on the ladder, set your climbing to true. Save that, back over into Unity. We'll see how we go with that step. I like to do things in small steps. Did that work? Did that work? Okay, that worked. Oh, that bit didn't work. So you know what step in the process is not working. Run, 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 touching the ladder. And as soon as I touch it, looks like he wants to climb, and now he's climbing forever. So it's great. We've got the first part of that, but we do have an issue in here, which means when you're not climbing the ladder, we need to set this back to false. So that right below our gravity stuff, I'm going to, you know what? I'll go down here and copy this exact line. My animator dot set bool is climbing will be false. We don't want to be doing climbing if we are currently not climbing. Save that up. We're currently not touching the ladder is our criteria in there. So we'll click on save and then play. Run, run, run. Run, run, run. Up, up, up. Down, down, down. When I'm no longer touching the ladder, I'm no longer doing my ladder animation. I think that's cool. Now, the problem we've got is that if I'm just sort of standing there, I'm doing this, it looks like I'm trying to climb up the ladder, and I'm not moving, so it doesn't make sense. I'd rather have the character play the idle because I can still move left and right, which is an okay behavior. I want that. I don't want to have a fixed no movement climbing. So if climbing was just one frame of climbing, then it would look like we're still climbing on the ladder, but if I move left and right, it look a little bit silly. You might want to have that behavior in your game. If you're on the ladder, you're locked on the ladder, you can't move left or right, you can't jump up and down until you get to the top. But for me, I want to be able to say you can come and go off ladders, so therefore I want to transition back into idle if we've stopped moving. The way we do that back in here, we've played around with this already, having movement velocity in here. Player has horizontal speed if this is true. So I'm going to copy all of that. So bool player has horizontal speed equals mathf.abs, etc. Jump down into our climb ladder. Right above setting is climbing true, I'm going to paste this in. Instead of player has horizontal speed, it'll be player has vertical speed. And the mathf.abs, my rigid body velocity.y is greater than mathf.epsilon. So if we've got any sort of up and down velocity, then it's going to be greater than 0, or mathf.epsilon. That'll be a bool. So instead of setting is climbing true, we'll set is climbing as based upon whatever our player has vertical speed resolves to. If that's true, then this will be true. If that's false, then this will be false. We can leave this one up the top here as false, because we want to be saying it's just false if you're not touching the ladder. We don't need to say the player has vertical speed is our bool condition up there. So let's save, see how we go with all of that. Click on our play button. Run over to our ladder, touching the ladder, but while still on the ground, nothing happening. That's good, that's what I want. As I climb up, if I'm climbing up and down, then we see the ladder animation, and if I stop, I see my idle, and I like that. That says, hey, I can now go jumping over there. Okay, so that's all good. We can't jump off the ladder because we're currently not touching the ground. That's okay. I don't think I want the player to be trying to do that sort of jump. I know that if you're on the ladder, you can drop off the ladder, which is kind of neat to jump off it, but you can't actually jump off the ladder. Yeah, that's cool. I'm happy with that behavior. If you wanted the player to be able to jump off the ladder, then you need to be able to say that it's not just the ground that's the determinant of jumping, it's also whether you're on a ladder. But I'm happy with that. And I'm happy with how our game is coming along. So good stuff. I'll see you in the next lecture. In this lecture, we're going to be setting up our Cinemachine follow camera so that we can finally run around to all the different parts of our level. We've set up Cinemachine before in the course, so if you already know how to do it and you want to try doing this on your own, there's the challenge for you. Jump in and do that. If you want to do this together, then let's jump in and take it on together. I'm going to open up the package manager and search for Cinemachine. Maybe we can do this as a little bit of a race to see whether you can set up your Cinemachine follow camera before I can. So consider that a challenge, a duel. I'm laying down the gauntlet. I'm installing Cinemachine from the package manager. If you currently don't have it installed in your project, you'll need to do the same. And I'll leave this whole stuff going on. So if we are doing this as a race, if you're saying, I'm going to set up my Cinemachine quicker than Rick, maybe it's dependent upon how quick your computer is and my computer, while we wait for all these aspects to load and install. Mine is now finished. Awesome. You can see the remove button in there. Should be there if it's all done and dusted. I'm going to click back on my scene view so I can see what's happening. Now I'm going to right click in my hierarchy, create Cinemachine virtual camera. I'm going to rename this to be, say, follow camera. You can name yours whatever you like. I'm going to drag it so it sits generally underneath the main camera in that ballpark, not as a child, just next to it. In the follow camera, I'm going to click on and I'm going to change the body to be a framing transposer, and I'm going to follow, click on the little selector on follow, we'll follow the player. Now if I click on play and click on the game window, or it should automatically go to the game window, you can see that we're running around. So there we go, Cinemachine, job done. Well, mostly job done. What I'd like to do is tweak it a little bit. So you can see it's quite an aggressive follow at the moment as we jump up and down. I think that's a little bit annoying. I want to soften that. I'm going to change the dampening. I'm also going to change the dead zone. So let's see. Side note, if we're having a race, this is probably the point where if you've finished, then cool, we've finished the race. I'm now going to tweak it a little bit and see what we can do. If we make the changes while we're in play mode, then we keep them. It's not a case that we lose them when we get out of play mode. So I'm just going to increase the dead zone width. You can see there it makes these lines open up a little bit, and the dead zone height as well. What that does is, let me just make this more pronounced. It means that I can run in that area, and the camera won't move at all until I get to the edge of the area. Then it will start to move again. I don't want to have it quite so wide, but we want to have a little bit in there, I think. A little bit of, say, 0.1 and probably 0.1 as well on the height. Now, the height, as I mentioned before, is a little bit more aggressive than I want, so I'm going to change the Y dampening. Might pop it up to, say, 5. See how that works? So that when you jump up and down, it slowly tries to find the player again. It's not going really quickly. But I think it's okay to go very quickly on the X and the Y to try to catch up to the player. You can see the yellow dot there is what the camera is trying to say. Keep that dot within the framing of what's our dead zone area. So we get out of the dead zone, then bring the dead zone up to it so it's touching it. So there we go. That's pretty much all I wanted to do. I might play around in the future with the lens ortho size. That's how you move the camera in and out. You can see the camera distance here doesn't do anything because we're currently framed on the player. We're using this framing transposer. But if I change the ortho size, I could move back a little bit if I wanted to have more level and less player, or move in closer if I wanted to get closer relationship to the personality of the player. I'm going to leave it as the default 5 for now until I have more gameplay in my game and see what I might actually need. But there we go. That's setting up the basics of our Cinemachine follow camera.